So as I was saying, our partners, we are glad to have partners today like A4Ayub Hands-on Labs and Deep Learning AI. So a brief introduction about deeplearning.ai. It was founded by Dr. Andrung, a global AI mastermind. It's making world-class AI education accessible to people around the globe and building AI community. So Pi and AI meetups are a series of deep learning AI meetups hosted in various countries around the globe. And something to mention, uh, there's an upcoming event by where Andrung will be part of the panelists, and it's breaking into natural language processing. So I'll drop the link in the chat section if that's something you want to register for. It's on 29th of July. And also there's a new course he launched on natural language processing specialization. So if it's something you're interested in, you can also register or register. I'll just put the link down. And our second partner, please, we can mute so that we avoid the background noises. So our second partner is A4Ayub Hands-on Labs. So this is where I can mention it's in Kenya. So it's where data scientists, machine learning engineers, and app developers acquire technical skills while solving real life problems. So as the lead, Robert Ayub, who's today our speaker, provides guidance and mentorship to the teams using project-based learning paths. So the problems are identified as a group and data generated, and all learning sessions are geared towards the delivery of a working and accessible solution to the problem. So our host, our speaker today, our speaker today, Robert Ayub, will inform us more about the A4Ayub hands-on lab. So stay tuned. Um, I'm sorry, there's someone with some background noise. Okay. So I'll take us through today's program. So from 9 a.m. to 9:20 a.m., I'll be taking you through the introduction and housekeeping. And from 9:20 a.m. to 12 p.m., we'll have the NLP case study, which will be facilitated by Robert Ayub, and he is a senior officer data scientist at Safaricom PLC. So please stay tuned to know more about the NLP case study and about the awesome initiative that Robert Ayub has started in Kenya. From 12 p.m. to 1 p.m., we'll have the Q&A session, which will be facilitated by Zakia Mustafa, as she introduced herself earlier. So some housekeeping, please mute your mic. The noise when someone is speaking, it really distracts, what someone is presenting. So please avoid unmuting the mic during the speaker session unless he asks you to. I don't know, I know he's a very interactive person, so he might ask you to raise your hand and then we can unmute you. So please ensure you have mute your mic so that you don't distract the speaker. And for the chat section, please feel free to chat and maybe write down or note down some comments or some links that you find useful, or also some questions that you might have. And then Zakia will facilitate the Q&A session and she will forward the questions to the speaker as he will be answering live. Okay, so you can also let everyone know of this amazing event via social media. So you can hashtag A4Ayub Hands-on Lab and also Pi and AI Nairobi, hashtag NLP, and you can also tag deeplearning.ai. I will share the links once more in the chat section. So without further ado, I know he's here, he's an early riser. So we'll have our NLP case study session begin, the fundamentals of building a retrieval-based chatbot by Robert Ayub, a senior officer data scientist at Safaricom PLC. So are you around?
Hi Rose, yes, I'm with you guys.
Okay, thank you. So as you share your slides or as you prepare, I will read some insights I got from your bio to just share with everyone before you can actually tell us what you do on a daily basis as a senior officer data scientist. So something about Ayub. Ayub is married with 3 kids and he has like 10 years cumulative work experience. He started working in a university known as JKUAT, which is Jomo Kenyatta University of Agriculture and Technology. It's based in Kenya, as a library assistant, and that's where he got his campus money. So you see, he's a really focused person. And he ran two parallel degrees while he was in JKUAT, with a business bachelor's in mathematics and physics, while he had another parallel degree in computing and information system in affiliation with London Metropolitan University. So he's also a multitasker. These are some things we are picking from his bio. So he took an academic leave to go to complete his second degree, and he had a chance to work with Dialogue Communications from Cape Town in South Africa. So when he came back to Kenya, he completed his first degree in mathematics and physics, and he also worked part-time in Kencall EPZ. So Ayub, you please inform us what Kencall EPZ is. I'm not really sure our youth of these days know that. And some brief work experience before you tell us what your current role entails. He worked at Popote Wireless, U-Mobile, and finally works at Safaricom PLC, transitioning from billing engineer to his current position as a senior officer data scientist with the customer channel section of the DIT department. So Ayub, please inform us about your role currently, and let's delve into the NLP session. Thank you.
Thank you, Rose, very much. Thank you very much. Hi, guys. I hope you guys are having some jitters like myself. You know, speaking in the public at times, it's a big problem. Right now, I'm speaking to the computer with how many people without faces? Approximately 18. Can I make a request? I need to see your faces. That is one other advantage of networking. So such events, we go to such events when to network and to learn. So I would make a request that we just turn on the video, unless you're of course having some issues with internet. Yeah. All right. So what I do in Safaricom, my day on a daily basis, it's largely on just looking at customer interactions, basically conversations from customers, and a lot of data, in particularly data generated from SMS. And I get to identify opportunities, not only on that data, but I get to identify opportunities based on some of the challenges you're going through within the customer channels. Customer channels is a section that largely it's a technical wing where it supports the call center. All right. Rose has done a very good job introducing my background. For a minute there, I thought she wanted to call me doctor. I'm not yet a doctor, but I hope one day I'll earn that title. Today I'm going to take you through. Rose, I'm not so sure if I'm able to project my screen to share anything on my screen. You might want to make me a co-host.
Please check again. I think I had disabled.
All right. Okay. I am able to know. Okay. I've mentioned briefly what I do on a daily basis in my current work. It doesn't really. It's not only on the text data that I explore, but so many other areas as well. And today's session is of interest because I tend to feel in my experience, little or small or young experience in the field of NLP. I think in the field of NLP, slightly less than a year or almost just a year in NLP. And the perception in the business and the expectations in the business is quite different from what is outside or what is being practiced, especially with the majority of people that I get to come across. So I felt it necessary to talk about this as just a guide, and I'll definitely touch on a couple of things. don't take it like a lecture. And if you feel that I need to explain something, or you feel like you have a question, just raise your hand. Rose will pick you up, and I'll stop, and I'll get back to your answer. All right. So what I'm going to talk to you guys about, by and large, what are some of the business expectations when any business is either getting a chatbot or thinking of implementing a chatbot within their organization. I'm also going to talk about what are some of the options available for developers. I know you guys do a lot of research and you read a lot. I've interacted with a lot of students, and I can confirm that you guys really, really do a lot of reading and research. So what are some of the options available for you as a developer or as a machine learning engineer? I'll also look at one of the specific options that are released, and then explore general steps when building a chatbot. I'll mention briefly about the different types of chatbots. We have generative retrieval as some of the contextual based chatbots. We'll touch into that. And then if time allows, I'll really try to make sure that all this is covered within the time that we have, so that you guys also have a session where we can now do Q&A. I'll illustrate sample code on Jupyter, from Jupyter. So if you have your laptop on, maybe you'll have some code writing to do if the time is allow us. But if the time doesn't allow, I'll just skim through the Jupyter Notebook, where I'll illustrate Spacey and how to do a very basic retrieval chatbot and highlight on a couple of approaches. Okay. So what are the business expectations from a chatbot? And I think our understanding of a chatbot is it's more or less a machine assistant. It assists you to do one or two things as within your business. So in this context, we'll think about a chatbot in a customer service area. So basically, if you look at huge companies or some companies right now, we have a pandemic. Some companies are not operating the number of maximum hours they normally operate. So some of the stuff that they do, especially informing their customers about their products and services, can easily be during the period that they're not operating. For instance, we used to have supermarkets operating 24/7, and then it went down to, I think, around 12 hours. And now with the pandemic, it's even much shorter. You can only imagine what that has in terms of sustainability of a company. Remember, the employees, they still need their salary. The suppliers have their products in the supermarket. So what are some of the ways to make such companies operate beyond the restrictions? They operate beyond the pandemic. There are specific things they are looking at. And one interest is, can we actually have a chatbot that will help us either self-serve customers from within our Facebook, Twitter, or even our website? And only we have essential, quote unquote, we have essential stuff that does delivery. So you make an inquiry, you interact with the chatbot takes your order, and then the order is made available to the essential staff. The essential staff makes the necessary packaging, and it's eventually delivered to you. Now that ensures there's continuity. There are other applications of a chatbot within the context of organization, and some organizations build chatbots to act like a supplement or as an assistant to a live agent. So we have live agents who actually are there manning the chat channel. So whenever you ask a question, excuse me, whenever you ask a question, there is a live agent to respond. But let's be realistic. A company that has approximately 100,000 queries every single day, and a live assistant is only able to handle maybe 100, for instance. 100 queries a day. So in an 8-hour shift day, we have an agent or a live agent handling 100. So with 100,000, you will need 10 agents. That's a bit manageable. With 1,000,000, you'll need 1,000, I think. Let's do the math. 1,000,000, how many agents? Anyone who's going to go through? There are some goodies. So if you keep quiet, you might not get the goodies from deep learning. So let's be interactive. That's the first question. I'm going to push it. Anyone? If you have 1,000,000 people and one agent has, one agent can answer 100 in an 8-hour shift, only 100 questions or support queries. How many people will you need if you have, say, 1,000,000? Okay, I can see someone has put on chat. Okay, it looks like, all right. So I'm going to pick, you know, when you're in my session, if I give you the opportunity to say, all right, you guys just got saved. But what I was going to say is, in any of my sessions, whenever I ask guys to be interactive and they decide to mute, a very, very common habit with Zoom, I always randomly pick, and more often than not, I always pick guys off guard. So that's gonna happen, and it's gonna be an interesting session. All right, 10,000, okay? So 10,000, you are going to employ, okay, let's bring it down. Let's be a bit realistic. 1,000,000 queries in a day is an overkill. Let's say we have 50,000. 50,000 query or 80,000 queries in a day. Let's work with 80,000 queries in a day. I'm waiting for the answer. Is it gonna be Joseph Kishui? Or should I pick someone else? 800. Good stuff. So you have guys doing maths. Okay, now 800. Each of those 800, you're paying them approximately 30, 40, or even 60,000 shillings per, you're paying them 60,000 shillings per month. So 60,000 shillings per month times 800, how much does that come to? Let's take this as an icebreaker, just something that is going to settle us in very well and to eventually get to understand and appreciate some of the values of a chatbot before we'll definitely eventually get to the technical. I know you guys really want to learn about the ML part of it. 48 million, 4.8 million, 4,000 K. Okay. All right. It depends on now the value that I'd given. I'd given like I think I'd given for 40,000, 50,000, 60,000. But I appreciate your feedback. Depending on now the variables you're working on, this figure is high. This figure is very, very high. Some companies spend approximately 200 million in a month just to pay support staff. And one of them is one of the supermarkets locally that has been reported to be struggling with employee as a result of the pandemic we are in. So the chatbot, before a business gets to, or even when a business is getting into the thought of getting a chatbot, they're looking at two things normally, but in broad things. The first one is the need to find a way of serving more customers without overhead, because if you increase your overhead as much as you really need to support your customers, you won't be making strides in terms of profits, and it won't be a bit realistic. Yeah. And then the second thing is you need customers to make to talk about your products and services. You need them to recommend your products and services to their friends, to their networks. So these two things, you need a balance, yeah? Or rather, the NPS, or something called NPS, Net Promoter Score, is just a measure of how likely one person is to recommend the service, the products and services of what you've bought from a specific seller. For instance, today we're talking about deep learning. After this session, how likely are you going to recommend someone to take up deep learning courses? Yeah. Or how likely are you ever going to listen to me when I invite you on the next session? So it all depends on your experience with the event. It depends with your experience after interacting with myself or any other speaker for that matter. So these are things that are very, very passionate to businesses and anyone providing a service, yeah, because it measures growth, okay? Now, some of the business metrics with regards to, let's come to now chatbot. You think of, okay, right, I've built a chatbot and how do you measure value based on what we had spoken about? We'd spoken about NPS and we'd spoken about checking out that you ensure that you support more customers as you grow. Because businesses, you definitely grow from one customer to another, from one customer to another. What if you reach a point where you have 10,000 customers and you started with one? When you started with one, you are probably the CEO, the procurement manager, you're the delivery man, but now you're 10,000. Are you still going to be doing all those roles? You'll definitely employ more people. But that employment has a limit, as I've explained earlier. It will reach a point where you'll need to control your growth of staff as compared to the growth of customers and strike a balance without suffering, right? So one of the metrics is after building a chatbot and after delivering a chatbot, you need to check the total users versus the chatbot users. If you have 10,000 users, you've successfully deployed a chatbot and you've observed it gradually grow, and on day, maybe say, let's say after 1 week, the total users, or even after 1 month, the total users and the chatbot users are head to head, all right? That is the first scenario. The second scenario is the chatbot users, no matter how, even after spending like say 10,000 shillings or even 50,000 shillings, you've actually spent money to market and make this known to your customers that we have an assistant who can help you when we are off working hours. So we are able to employ people within the curfew hours. And then after the curfew hours, we are working with essential service providers to continue giving service to you. So you can still order from our supermarket and you will get what you want, okay? Now, if you figure that the number of chatbot users is less, then that is an indication of some actions you need to do as a business, all right? Now, that is total users. The second one is new chatbot users. What are the rates in which you acquire new chatbot users? Yeah, if new chatbot users keep growing at the rate of you expanding, so you get your total chatbot users grows and your new chatbot users grows. So once again, they are head to head. So that is an indication of, it's a good metric. Ideally, that is where most organizations would want to be. Yeah. So as an ML engineer or as a developer, you need to be aware of the expectation of business and how they actually measure the delivery, so that when you're implementing or when you're choosing a way to build your chatbot or when you're choosing a way to design your chatbot, you're aware of the expected metrics. It is beyond the normal F1 scores and accuracy that we work with when building the models as machine learning engineers. You need to have this thought of, you need to have this business acumen of how business looks at the work engineers do in order to make sense or to judge the delivery of whatever it is that was built, right? Now, new user metrics is another one. It's still a user metrics. And then there's something called the bounce rate and the completion rate. So bounce rate is I start a conversation with a chatbot, and then along the way I drop off. What is the rate of customers' conversation dropping off within, say, within a session or within a certain conversation. Yeah, that is another metric. Completion rate is whatever it is I came to chat to do, or whatever it is the chatbot was helping me to do. Did I walk the journey to the end, or it was not completed? If I wanted to say, this is a chatbot to help me do shopping. I started the shopping, and I did not complete it. I did not complete it, not because of any other issue, but it could be because of maybe the checkout was just so frustrating, and I wasn't able to. I was basically not assisted as much as I was willing to be assisted. So the chatbot gives me this answer. It gives me this URL. I go to that URL, and you can actually see the system. We are struggling to figure out how I should be sorted as a customer. So eventually I just throw in the towel, and yeah, I move on with my life. So this is another very, very important metric used by businesses to check and validate the value a chatbot gives to the organization. Session duration. Now, session duration is now when you're looking at the entire session end to end. From the time I visited this site, or from the time I visited this Facebook page and it has a chatbot, all the way to the end, where I say, okay, thank you. I think I'll get this service, or I think I'll try again next time. So whatever happens during that session, it's a combination of bounce rate and goal completion. So the entire session could last, say, 15 minutes. And if I was shopping, did I successfully check out? And during that session, how many people actually just dropped off the window of that 15 minutes? How many people achieved whatever they were trying to achieve within that window? So that measure of session duration is very, very important to any business trying to implement a chatbot. Now, there is something called agent takeover. So there are certain chatbots that has this capability. There are other chatbots that don't have this capability. But whichever way, if you implement and if you implement agent takeover within your chatbot, it's going to give you leverage. So in the event that the chatbot is struggling to serve the customer, the chatbot could always just handshake with the agent and forward the message to the live agent, so that the live agent can pick up. Now, what is the rate of this takeover? Is the chatbot just passing? Is it just passing messages? Say, for instance, the assumption would be the very first instant, or the very first thing a customer interacts with will be the chatbot. The chatbot welcomes you and offers to help you, and then you shoot your question or your comment or your complaint or your inquiry. Out of the queries and complaints that have been asked by the chatbot, how many can the chatbot actually answer? And how many will the chatbot forward to a live agent? So if the chatbot answers quite a number of questions and forwards less, then one of the objectives that we had mentioned earlier of checking out and controlling overhead, then that one is a valuable chatbot, and it can actually give value to the business. But now there is one thing of the chatbot answering accurately and the chatbot answering more. So a combination of both is actually the desired value. So one, the chatbot needs to answer more questions. And two, the chatbot needs to answer those questions, needs to be as accurately as possible. So the objective of a machine learning engineer is to ensure that if you choose to use contextual chatbots, which I'll talk about in a few minutes, then it means that this one is being built by a machine learning engineer, and that becomes then the value of your work to the organization. Yeah. So let's not confuse it. There is a very, very big, huge discrepancy between the reality on the ground and the perception. So the moment you go to production, the value you give to business shifts from the F1 score, like I'd mentioned. It shifts from the accuracy. It shifts from all those technologies that you've used to a simple thing. Two, actually. The first one is your chatbot working. The second one is your chatbot relatively smart, acceptably smart. And there are ways of measuring both, and it won't be measured by all the other metrics you learn when you're building using machine learning. Okay, so it's very, very crucial that we all get cognizant of the expectation out there and what is going to guide delivery and value to business. All right, there is another metric called CSAT, which I've hinted in the previous slide. CSAT is basically customer satisfaction metric, and it by and large delves in NPS. NPS had mentioned earlier, Net Promoter Score. How likely are you going to recommend the services and products of an organization to either your peers or your friends? It's normally a score. Some people put it a score between 0 to 10, 0 to 5, 0 to 7. But it's with 1 either being the lowest score, 1 to 10, 1 to 5, 1 to 7. So this metric is normally very, very important to understand how, if the chatbot is smart. And you can take it from me. It's a real nightmare to chatbots, people building chatbots, and because the person evaluating you has no idea about machine learning, they just want to get sorted. The person measuring your performance or your assistant just needs to get sorted, and that person is our customer. So every single thing you need to do it thinking about the customer. It's not the metric. The metric takes you to the level and lets you understand. It lets you understand how the probability of the customer accepting the answer, or even yourself understand how you've technically built this model. But you'll face scenarios where your model has really, really good results in terms of the metrics you're used to. And even your peers will be like, yes, I think we are good to go. But before you go to production, you must put it through a process called a QA process, where you take real live people to ask it questions, and questions, just random questions, and then judge it by yourself. Out of 10 questions, how many came out okay, and how many were just a disappointment. So you go back and do it again. And this can happen even with good scores, good F1 scores. And so this is, it's like you're in a laboratory. So it's something that most businesses, they know how to tell a smart chatbot, and most customers normally do. Most customers know how to tell a smart chatbot, one that is trying and one that needs a lot of improvement. And you will come across this. So that is Net Promoter Score. All right. Now, there is another one called retention rate. Say you walk into a supermarket's website, a supermarket website where you interact with a chatbot. They just released their chatbot, and you go through it and you experience it, and then it routes you to an agent, and maybe you get sorted. The next time you go back and you interact with the agent, with the chatbot, the next time, and you realize that, okay, the other time it wasn't able to answer this. This time I've asked it, it's actually improving. So there is one thing to answer incorrectly, And there is another thing to ensure that the chatbot actually lands within a faster pace, or rather, because customers at times can not are never like patient when it comes to service delivery. Yeah. So the faster and turnaround time to ensure that your chatbot lands, the better. So the person who visits this website and interacts with your chatbot, the first day they might be patient. Okay, they've released. Okay, now that's nice. At least it's saving me going to the supermarket. So customers at the very, very first instant, they will be very, very optimistic, and they are more likely to like to support you and understand. And you see, make noise about it. Oh, these guys, they're doing this because it's working for them. You can imagine you're in the house and you need something, and there's an option of just going and talking to a chatbot and having it delivered to your house. You'll definitely be excited about it. So the first instinct would be to shout and promote it. You'll be a promoter by default, okay? Now, you go there 2-3 days. On your first day, 1 or 2 questions were missed, and you shared your thought, and you gave your feedback to this company or to this supermarket. First, they never acknowledged and they never appreciated you. And then second, you go back to the website in 3 days later, or maybe 4 days later, or even a week. Okay, because some of these things, they take time, even a week, and you realize within that period, whatever it is that was done has not been sorted. So you'll start detracting. So you'll start shifting from a promoter to a detractor. And when you move to a detractor, you'll eventually churn from that channel. You'll say, okay, now this channel, this shopping from the website doesn't work. Let me just go to the supermarkets. And you become now a walk-in customer, right? So what is the retention rate of your chatbots? Are guys going to come back to it and use it? Are guys going to start even putting suggestion on what else it should do? Are guys going to now start participating in the developing and making sure it's good? So the moment you see such trends, then it means there is something you're doing right. And trust me, no chatbot is perfect. There is always areas and room for improvement. Okay, so retention rate is another business metric. Those are very, very clear metrics and metrics that resonate very well with customers. And I think you'll agree with me that once or twice or even 3 times, you felt disappointed by 1 or 2 chatbots that you've interacted with, and you felt that it's a stupid chatbot. You could be in a rush, and you judge and conclude that this is a very, very stupid chatbot. Okay, you could be right, and because of that, I would want us to go through some of the options available for developers, depending on the need. Yeah? And as we move, please don't forget anything that we've discussed in the previous slides, because they guide what we are talking about. They are going to guide what you're going to be learning in terms of the decision you're going to make, which approach. So there are 2 things you need to take from previous slides to the next slides. One is that the metrics for NPS, Net Promoter Score, and the metric of reducing live agent assistant. Okay. The objectives, sorry. Oh, the metrics, we've covered them. The objectives of any chatbot, those 2. So what are the options? What are the options for available to developers? We have menu-driven or button-driven chatbots, and they're very effective in their own way, and they give specific results that contribute to benefits to an organization. And we have keyword recognition chatbot based on the presence or absence of specific keywords. And then we have contextual chatbots. So the complexity increases as you climb the pyramid, and the benefits and the potential benefits in terms of the user experience also goes up. All right. So if we look at menu and button driven, let's look at it like an hierarchy of decisions. I don't want to use decision tree. In this case, it's not the decision tree that we've all come across in machine learning model. It is just a tree, a hierarchy of buttons, for example. So if this user clicks on this button, the next layer of buttons is this, and then the third layer of buttons is this, depending on what the user wants to achieve. So it's like you're going into levels of you're being guided into several levels before you get to your solution. It has advantage in terms of actually achieving the customer's objective. Yeah, in terms the bot is less likely to misunderstand your intention. For as long as your intention is within those buttons, then it will actually eventually get to answer your question. But it also has its disadvantages, where how many buttons will we ever have? How deep will we ever go? Is it sustainable for large queries? And is it sustainable for complex user queries and user complaints? That is a question that the business needs to answer, or the decision maker, the developer actually needs to answer. Is it sustainable? And what kind of customer are we talking about? Is it a small retail store with around only 10 FAQs? Or is it a huge retail store with several branches that a question could be confused? And is it practical to have menus for all those? How can we scale, especially when we have products? And even if you take one retail store, if someone wanted to shop, how many products a retail store has? Thousands, tens of thousands. So building a chatbot for shopping using buttons, it's possible, it's achievable, but it might have implications on the user experience. And the only way to learn about this is, of course, from the metrics that we've discussed previously, observing and learning the patterns of your customers as they shop. So that report is very, very important. If it is working for you, the previous metrics will actually tell you it's working for you. If it is not working for you, then the same metrics will tell you that it's not working for you and you need to change. Now, if we go to the keyword recognition based. So for keyword, it's the first option within keywords is to scrap off buttons. So we allow customers to key in, to type their words, but we write code or we build logic that would look for specific keywords or even specific patterns within that message. And then we try and generate an understanding of what the customer is most probably asking, and then we give the most appropriate answer. So we look for the presence of specific keywords in a sentence, and if that keyword is present, then it's sort of contributes to the next question or answer the bot is going to ask or answer. So if it is a simple, straightforward question and the bot quickly picks the keywords, then the bot is most likely to answer it and ask for if there is any other thing they can be of assistance to. This again also has benefits and also disadvantages. So the moment you shift from menus to buttons, to menus and buttons to keywords, you're opening the floods of chaos, if I may use that word. So menus and buttons is a bit controlled. It's a bit clear in terms of troubleshooting, in terms of, but when the moment you move to keywords, we all know that there are certain keywords that either overlap contexts, And by context, I mean conversations. So I could use a keyword or a couple of keywords could be present in one conversation by one customer, and the same set of keywords could also be present in another conversation by a different customer. But these are different customers who want different things. So if you pick the presence of those keywords to these two different customers, you're most likely to disappoint one of the customers because you've misunderstood it. I've used the same keywords, but I wanted something completely different. Yeah, when you're doing service-related chatbots, then you will come across many of those, right? Now, another thing is for keyword, it doesn't have context. It's just, you're just looking for that, the presence or absence of that word. Yeah, let me keep it simple. If you were to do a sentiment analysis and you are to use keyword, you just look for positive words and negative words and make your interpretation. How then will you handle things like, say, sarcasm, or how then would you handle things like ambiguities? Yeah. So the tool that you use depends on your target customer and depends on your objective. What do you want to achieve? But keyword is slightly, it looks slightly more intelligent than buttons in terms of the customer keys in and there is a reply. So whether you write a million lines of code, and this is where it gets interesting, whether you write a million lines of code and you are able to sort out the customer will rate you highly, yeah? But back in the office, you'll be rated poorly because how can you have a million lines of code in this current day and age? But the business will be happy. No one gives a hoot, especially the business. No one gives the hoot of the technology you use, especially if you're not in technology, meaning IT department. When I talk about business, it's those guys who interface with customers, who talk revenue, who talk, for as long as you can make the customer happy, they're your friends. But when you're in technology or IT department, you will have problems with your boss. They will give you the shortest time possible to change your code, to make it more sustainable, and to make it in line with current trends of development practice as a developer, okay? Because it has a lot of benefits. So when you write a million lines of code, it is your manager you're giving a nightmare now, yeah? In terms of how to scale that code of yours, how to manage it, how to support it. It's him you're giving a nightmare, and he's not going to allow that, all right? Now, we shift now to contextual. Contextual chatbots, they maintain state, they maintain a conversation. They put everything into context. So the answer that the chatbot gives is it's a well thought answer. So it puts a lot of other things into consideration before providing the answer. For instance, not only looking at the presence or absence of words in that text, but how do they follow one another? How are these words arranged? Which word comes before the other? What was the previous sentence from the customer? So it depends. Now, right here, we are going to do, with contextual chatbots, the first thing you need to do is a lot of text analytics. You'll just apply a lot of statistics in your text and try and understand and generate certain things, okay? So that is a difference of the various types of chatbots that we come across as either machine learning engineers or developers, okay? All right, now, which one do you choose? Yeah, that is the big question. On one hand, you have low-hanging methods, easy to implement, and you can turn around faster. On the other hand, all of them seem to be giving a solution. So which one do you choose? You should be guided by the one that is going to meet the objectives of it's going to meet the objectives of the customer. In this case, the customer is the person you're building the chatbot for. I think there is someone who needs to mute. All right, let's continue. So the decision for you to choose the chatbot to use is driven by which one is going to help you meet your objective, business objective, in line with what we did earlier. Contextual chatbots. So we've seen it's at the top of the pyramid for all the good reasons. Not to by any means does that communicate that the other two are not relevant. They provide solutions, and actually there are some benefits on many bits that contextual, as you will later see, contextual chatbot actually struggle with. Yeah, but the freedom and the freedom of its operation tries to mimic the natural way of a conversation. And that brings the idea of natural language processing. So can I ask in a supermarket, naturally, through these digital platforms, can I just ask, like, by the way, you guys, why are you guys expensive than the other people? And then that question be answered by a chatbot. How will the chatbot know the other people? How will they know? How will the chatbot just infer or derive meaning from that text that I asked? No button. In that sentence, there's no keyword. I didn't mention blue band. I just said you guys are expensive than the other people. So there is a context here. Expensive, other people. Other people could be competition. Can the chatbot understand that whenever other people comes before expensive, or can it derive a meaning out of that statement that actually this customer, what they're trying to say is our products and services are expensive as compared to competition? All right. So contextual chatbots puts everything into context. And that's now the introduction to machine learning and artificial intelligence as an approach to build bots that are conversational, ability to remember. And there are several approaches, even within the contextual chatbot. There are several approaches for building contextual chatbot. But before we get to the approaches, the diagram that you're looking at is a high-level design for a generic chatbot based on what we've discussed so far. So let's walk through it. So we have a user interface. It could be a Facebook, it could be Twitter, it could be a handset, that is SMS, whatever interface that you're talking about. And it could be even a machine, right? What you don't know is this concept of chatbots and robots, they are older than almost everyone in this forum. 1950s, in the 1950s, we already had this stuff being done. I'm not 1950 to this year is, no, I'm not that old. So some of these things, the people who wrote these papers and the people who struggled up there before us, I believe they've made life simple in terms of understanding some of these concepts. And that is why some of these things appear simple, though to some extent, as we will see subsequent slides, they might look a bit expensive or in terms of understanding, and they might look a bit complex as well. So user interface, depending on the interface that you pick, the user pushes a request. It could be a question, an inquiry, a complaint, whatever it is that you're building. And as I mentioned that, let me also mention that we have two types as well, two types of contextual chatbots, or rather chatbots in general, where we are talking about vertical chatbots and horizontal chatbots. Now, vertical chatbots are basically, they are refined within a certain domain. a certain domain. So you're training the chatbot to answer questions within a certain domain. It could be, say, a chatbot that is very, very good in IT department. So any question about IT department, availability of spare parts, a support request, you don't have your software. So you build and design your chatbot to a specific domain. So this user request will be for that domain. How then do you handle any question outside the domain? Is there a question? Are we together? If you're okay, if you have any issue, please just type on the chat, and Rose will stop me, and I would address it. If I am not audible, if I am too fast, at times I get carried away and I forget everyone. And when I engage gear 4 and some people are still in gear 1, for those people who know how to drive, please just tell me, boss, driving while drunk is not good, so take it easy, and I will heed to your advice, okay? I'll come back to gear 2 and some sober speeds. So let's go back to this slide. User request. How then will the user request, how do you handle queries coming through that are for a different domain? So those are things that as an ML engineer, you should be aware of when you're designing and building your chatbot. Now that was vertical chatbot. Horizontal chatbot is open domain, yeah? Each chatbot, it's just for people to talk and try. And we've experienced some of them. Google Siri, Google has theirs, Apple has theirs. There are quite a number of people who build chatbots to just answer anything you can think of, yeah? And they will attempt to answer, all right? That is the difference between vertical and horizontal chatbots. Now, you move into your logic built by you and your team. The first thing you need to do is to try and understand this message, what is it about? And that is what is called the user intent. What does the user really want? So if we stick to the IT help desk kind of chatbot, the broad domains within which a chatbot could offer help would be either it's a hardware query, either it's a software query, either it is an access query. A user wants to give access. So those are three broad categories of the chatbot offering help. So when you need to drill down, okay, it is an access query. What about that access? Or it is a hardware query. What is it about the hardware? Do you need replacement? Do you need a new laptop? Do you want, if it's software, do you want a software installed? What is it about? And all this understanding is to be done by the chatbot, yeah? And while doing that, there is need to derive and understand what was the context of this discussion, yeah? What are some of the things that revolves around this discussion? So the board needs to be aware in terms of there might be need to pick things like what time this conversation is happening without even explicitly mentioning that it is a date. If it was a flight booking system and the customer just said, please book my flight to whatever, to Kisumu tomorrow, and I'm going to pay through M-Pesa. There is no explicit mention of a date. There is no explicit mention that Kisumu is a place and I'm going tomorrow, which is 26th of July 2020, and I'm going to pay using M-Pesa, and the amount I'm paying is 7,000 shillings. So those two statements differ. A keyword chatbot will need it explicitly mentioned as the latter. So I will go like, my name is Robert Ayub Odhiambo. I am planning to travel to Kisumu, which is a place, tomorrow at 6 a.m. Tomorrow is 26th, and I will pay using M-Pesa, and the amount I'm paying is 7,000 shillings. If you're looking for keywords, then that kind of query would make your life easier as a machine learning developer. But the customer is not out to make your life easier. It's actually you who needs to make the customer's life easier. Why are you making your customer mention all those things? Yeah, and there is technology to enable us learn those stuff gradually. So that is a context that needs to be picked. And this together with the dialogue management platform. Dialogue management is just a workflow. I would say it's like business logic, where you're implementing the business logic based on, say, if the date conflicts, if you're picking like now, I want to think, okay, let's put it this way. Dialogue management is where now you're implementing the business rules of that chatbot, depending on certain requests from the customer. So for instance, let's go back to our IT help desk example. A user request for access, and a business rule says that access to this platform is only by this level of, you need this level of clearance. The chatbot doesn't need to proceed any further. The chatbot then tells that, sorry, kindly request access from this, or fill in this form, or do you want me to give you the link to fill and make the request? Or, you know, you're offering help. So maybe the user went, I need access to this. And he or she doesn't know what are some of the controls for that access. You might want to validate that from a dialogue management, and it basically looks at the state as the conversation changed from one state to another. Another thing you can implement in dialogue management is tracking through the start and end of a session. And a session is like a conversation with the customer. So is it a new conversation? Is it an ongoing conversation? And as this conversation come to an end, so that is where you also implement that tracking, right? Now, based on the dialogue conversation, dialogue management, there is the chatbot needs to understand, okay, now this is a pass, what should I do? The chatbot will now then, okay, now this customer wants access, but he's not cleared. What should I do? Should I just tell them, hey, dude, you don't have access. Go back to your manager and talk to your manager to get access, and then come back. I will sort you out. Yeah, should I do that? Or should I tell the customer, okay, you don't have this, but I think this information will be helpful for you to get started. If you have queries, let me know. So that is a chatbot that actually understands what they need to do. And that is where action execution comes in. What needs to be done? Now, if the chatbot understands what needs to be done, then they need to retrieve the information or the answer. And they're retrieving this information or the answer, or even the questions, from various data sources. So this architecture or this design can change depending on so many other things. What you want to achieve, how many data sources, how many. It's not like a blueprint where you just pick and go and copy. This architecture changes a lot depending on what you want to achieve. All right. So it's a high-level contextual diagram for a contextual chatbot. I had mentioned that a contextual chatbot considers quite a lot of stuff before providing a thoughtful answer. The first thing is, what is the domain? What is the topic? What is the subject about? I was only trained about pizza. Ask me anything about pizza, and I will answer. Now, for those guys from our international brothers and sisters who have joined us, there is something that a delicacy that Kenyans really like. It's called githeri. When you come to Kenya next time, make sure you ask for githeri. Now you train a chatbot to answer about pizza. And then one Kenya decides, okay, and they always do. We always do. You're told, hey, this company has launched a chatbot. You immediately forget that that chatbot is for that company. And then you start asking that chatbot question like, are you married? Are you beautiful? Are you single? That happens, okay? It's because for the fun of it. So the decision on whether to integrate those kind of questions to your chatbot remains with the intent. So if, remember we discussed the retention rate of chatbots. If you omit that kind of discussion in your chatbot, then people might find your chatbot boring and just off and so rigid. And we're in the social space, a social space where people are free, people are happy, people are just in their own good, happy world, okay? So they shouldn't be restricted. So that decision is a balance. But then again, you also don't want to overdo it, so because as a business, your objective is to serve your customers, yeah? So those things like now, are you married? You can imagine if you didn't have a chatbot, this question is going to a live agent, because also those questions come. They come. So those questions, they go to a live agent, and the agent, instead of spending time answering another customer whose order has not been delivered and is really, really frustrated, the agent is forced to answer, are you married? So these things, the domain within which your chatbot works is very crucial. What is the situation? And what is the vocabulary? Within every business, there are certain terminologies, or rather there are vocabularies that guide our operations. Yeah, if it's a telco, if it's a bank, if it is a credit company, if it is a supermarket, there is a certain set of vocabulary. So, for instance, if it is a chatbot for a telco, I'm so sure in the vocabulary database or dictionary for the telco, you won't get things like bread, pork, nyama choma. So whenever such vocabulary are missing, how then do you handle them? And it also depends on the kind of chatbot you're building, on kind of the technique you're using to build that chatbot, okay? And I will come through to that in a short while. The persistence with regards to answering the questions, the emotion of the chatbot. Is the chatbot empathetic? Or is the chatbot just flat, plain like a machine? You complain that I bought this thing 2 hours ago. I did shopping 2 hours ago. Until now, I've not received a call, and this guy is not answering my calls. How will that chatbot understand? Or what's the first thing that the chatbot should do after understanding that, okay, this is a complaint? So there are two things. The first thing is, okay, the chatbot might not even understand that this customer is complaining, but the second one is the chatbot actually understand that this customer is complaining, depending on how it was trained. Is the chatbot empathetic by first offering an apology and understanding and bringing down the temperatures? Yeah. Is it possible that you plug in some sentiment analysis in your chatbot to make it like human? Because chatbots do not serve other chatbots. They serve human beings. And human beings have certain things that chatbot will never have. Things like emotions. Yeah. We can only try and mimic emotions. We can only try and derive, but we can never make a chatbot have emotions. Even the robots that are being built, they will never have emotions. But there are some that are really, really good in terms of how they were built. It's just amazing. All right, personality. When you interact with this chatbot, what comes with you? And this personality is derived just based on the wordings and the answers the chatbot gives. Is it a plain? It's related to the emotion I had mentioned. Is it plain robot question? This is your question. This is your answer. Move on. Do you have any other question? Yes. Okay. Tell me. Or is the chatbot a bit? Does it have a personality? And the personality in this case is you need to have a chatbot that has a personality of a customer care agent. And customer care agents are trained. They're trained to be empathetic. Yeah. Even if you're having a rough day, you'll put that aside and try to be empathetic and make someone else happy while you are going through a lot of problems. So that is a skill, and it's a very, very special skill by customer care agents, right? Now, maintaining a conversation. I want to go on vacation. Yeah, look at the chatbot's response. Let's do it. Who's going? Just me. Perfect. Where would you like to go? So these are four sentences, but the fourth one is an answer to the first one. So there is a way that the bot or the chatbot is putting everything into context. You can actually get out of a conversation and then come back, find your way back to a conversation. It's just like I'm talking to you guys right now. You can interrupt me and ask me a question. Ayub, by the way, last week you promised me lunch, but after this, let's have a conversation. Yeah, I'm really, really sorry, but after this, I'm going to reach out. And then we come back to a conversation. That is very, very natural, yeah? So can you give that capability to your chatbot? And with keywords, I want to pose a question. With keywords, are you able to achieve something like that? Can you jump out and in conversation using keywords? So those are some of the limitations. So you need to understand what exactly is the objective of the chatbot I am building. Okay? All right. Now, whenever people talk about chatbots, especially people in business or just guys who are starting to learn about it, and but mostly this comes from customers they're looking for someone to build a chatbot. They're understanding that this thing is so you just type and you give it a response, and yeah, that is what most people think. But the real people who understand the nightmare that goes through and what the expectation of the business are the machine learning engineers and the developers. It is actually something that is not easy in the past. But now, assume you're employed, or rather you're looking for employment. Let's go with employment as an example. You're employed. You're aware of the business expectations. We've covered that. You're aware of the business expectations, and you're aware of the business metrics. And fortunately for you, you actually know which contextual chatbot to use. How long do you think it's going to take you to build a contextual chatbot? Some people would say it's a week. Some people would say it's a month. Some people would say it's 2 months. Some people would say it's 3 months. Some people would say, okay, for us guys to come up with something really, really good, we need a year. We need a year. We need 6. We need 6 months. Yeah. So 2 things have happened in the past. No, you cannot deliver this project in 6 months. That's crazy. We need impact right now. We need it in a month. Okay. You have no say. It's either you take it or you look for another job. All right, you take it. Now you struggle. You struggle 1 month. You fight with your boss. Words are exchanged. You seek for extension. Yes. Okay, now I'm giving you another month. I say no. I need 6 months. The fight goes on. On the 6th month, you deliver your project. Yeah. But there is a way of, after understanding the general process of building a chatbot, you'll get to appreciate that actually there is need for a deeper, there is need for a lot of time, relatively longer time, to build something and deliver it to your customer. Let's look at the techniques. Whether it's keyword, whether it's menu-driven, whether it is contextual, but this one go a lot. Menu-driven might not be amongst this, but for keyword and for the contextual, you'll either use one or a combination of the technologies that you're looking at. Excuse me. I want to pause right there for a few minutes. I just need to feel what is the thought like. I just want to feel from the audience, just randomly, if you are courageous enough, just unmute your mic and just share what you think so far in terms of are you getting anything? Are you lost? Do you have a question? Are some of your answers being some of your questions being answered? Anyone, it is open. Please don't embarrass me by just keeping quiet. This is an opportunity. Just I need 1 or 2 or 3 people just to talk before I proceed. You know, I get that a lot. Oh, Emmanuel has raised his hand. Okay. Rose, do you mind unmuting Emmanuel? Emmanuel, please go ahead.
Hello. Yes, are you?
Yes, go ahead, Emmanuel.
How are you?
I'm fine, thank you.
I appreciate the session. I think I'm learning a lot.
Okay.
And since I'm just an upcoming machine learning and data scientist, I think I'm getting a lot.
Okay.
The session is enjoyable. It is on point.
Good stuff, Emmanuel.
Yeah. Okay, thank you.
Stay with us, Emmanuel. Any other person who wants to break the ice? Any other person who just wants to speak?
Hello, Robert.
Hi, Adnan.
Yeah. Do you have any comparative slide of cloud chat solutions like Dialogflow, IBM Watson, and any other? So you have any comparison of their costing or price comparison?
Okay, Adnan, I didn't do that. I didn't compare the available options in terms of price. Today's session, I stuck on actually what are some of the things to consider when you're building a chatbot. But if you might need that, maybe for another session.
Yeah. I would be interested that the people are using ready-made solutions and they are just integrating their chatbots
Yes.
with existing something.
Okay.
So if you can share later after the presentation, I'll be happy.
All right. All right. You'll share your contacts and probably I'll look around and come up with a write-up. Yeah.
Thanks, Albert.
Karibu. Welcome. Any other person?
Hi, Ayub.
Hi. And who is that? That sounds familiar. That's Eunice. Okay. Eunice, go ahead. How are you doing?
I'm fine. So I joined the session late, but not so late. So what I would actually say about the session is that thank you for breaking down the complex stuff into chewable and digestible bits. And I'm motivated to have a chatbot.
Awesome. Awesome. And Eunice, I don't want to jinx. I don't want to spoil the test. In the next couple of slides, it might get a bit complex. but I'll try and maintain the breaking of it into pits that you can actually eat. But thanks for the feedback. Good stuff. All right. Now I'm going to allow each and every one of us to be free to interrupt me at any given time and ask a question. I love it when if you're in such a session, after the period that we have, say 2 hours, you don't feel wasted, because I am so sure that there are so many other things you guys would rather be doing, but you're here for a purpose. So if you're here for a purpose and you're not meeting that purpose, then by all means, try and get the answers you deserve. At least for 2 hours, you'll say, okay, at least I got this. I didn't waste my 2 hours. So I allow anyone to stop us and ask questions and ask for answers. All right? Okay, let's go back to the slides. I was saying, when you're building a chatbot, and Adnan had mentioned that there are ready-made solutions, which is very, very true. So because of the challenge I had mentioned previously, and because of the expectation of the business, certain companies have come up with ready-made solutions that just needs a few training, and they have documentation of how you can train ready-made bots with your data, with your domain data. One of them that has been mentioned by Adnan is IBM Watson, and we have Dialogflow. That one was, I think it's driven by Google, if I'm not wrong. And there are so many other. So depending on the business needs and the time that this needs to be done and the availability of the technical skills, then you could explore those ways. And most huge corporates, they adopt some of this. Solutions because of the quick turnaround time. Yeah. Maybe later, for another day, I would try and explore the advantages, the pros, the cons, and do a comparison as proposed by Adnan. Adnan, I'll check that up. And if you're interested in that kind of info, just make sure that you leave me your email. I would share that after figuring out. I'll share that information. That is one of the way. But if we go the other way, where budget is a concern, where you want to empower skills of your either staff, or worst case scenario, you're actually the one who wants to go and get employed by these companies. How will they then know your capabilities? But how will you even know which chatbot framework they're using? It will be difficult for you to know whether a company that you want to work for is using IBM Watson or Dialogflow, unless you know someone there, or unless they make it public. Yeah. But before then, the thing that you can know, because all these ready-made solutions, they are built and anchored on the fundamentals, and the fundamentals are what we are going through today. So if you can acquire those skills, then regardless of the technology being used, you will quickly adapt to the methodology or the tool they're using and be able to ace an interview. Now, NLP. This NLP stands for Natural Language Processing. We have deep learning and we have machine learning. Deep learning, machine learning is like compiled together into artificial intelligence. Now, there is a completely new, there is actually a completely separate theory on each one of these, but I'll quickly just go through each one of them high level. So machine learning, deep learning, they're both AI components. So AI basically means the ability to make inference, like to enable machines make inference like humans do. So by that I mean, let's give an example, and I normally use this example in my class. A child has no idea of what is wrong and what's right. A child doesn't know about getting sick or not getting sick. They just know that I'm not comfortable, I need to do this. I am comfortable, I need to do this. Yeah. I feel happy, I need to laugh. I've messed myself up. I need to cry so that someone comes and clean me up. I'm feeling like I have fever. I'm not comfortable. I am sick. I need to cry so that someone can come and help me out. Who tells the baby to, okay, now start crying? And this is just a baby. Who tells them? So there is some natural intelligence that all human beings have that is just, we are born with it, yeah? You see a lion, you need to take off. And it's because maybe as an adult, you've grown where you've watched movies, you've watched series that people take off whenever they see lions. But let's think about it. Have you not also seen movies where, or even videos circulating in the internet where a child is just seated next to a snake, or even seated next to an animal that you're so scared of, and the child feels nothing. And the snake also does not harm the baby. Yeah. So there is some natural, intelligence that we human beings have. And now when we try to pass that intelligence to machine, that is what we are calling artificial intelligence. Now we are trying to translate that intelligence and enable a machine to have it. In this case, we are not trying to make machines cry, but we want to try now in the business world. We want to try and make a machine think like a human being and try and figure out this data. What is it telling us? Are we able to, is the machine, can the machine, the way you can be seated as a manager or as a data analytics person, making certain decisions that are strategic to the business, and you're guided by data. Are you going to do it from ground up, or would you rather some element of your job be done by the machine that it makes it easier? Like creation of specific dashboard that when you look at them, you realize, okay, so next week on Friday at 10 p.m., we are likely to get 50,000 calls to the call center. Then I need to make sure that we are adequately equipped. And more importantly, I need to figure out why are these people going to call me so that I try and avoid those calls. I sort them out before they call me. That is forecasting. And we do it using machine learning, either machine learning or deep learning. Now, with deep learning, both of them are artificial intelligence. With deep learning, it's just the approach and the technique being used. Yeah. So the thought process for deep learning is anchored on the way our neural, our brain works, and through neurons. Yeah. So like we have neural networks. So I wouldn't want to go further. In the next slides, we will go a bit further on that. But for this particular slide, just know that for deep learning, it's a technique that is different, and it's anchored on neural networks. So the way one neuron communicates to another, and then they pass the message. In this case, let's look at it as a message. If you've ever watched a sport called short relay, where people run, for those guys from other countries, Kenyans are known to be very good runners. But now marathon, not short relay. I think Jamaica is good in speed, where we have Usain Bolt. But here in Kenya, there is a sport called short relay, where you have like 3 people. You have 3 people, and each person has a distance to cover. So you're given a baton, and you need to sprint as fast as you can and pass it to the next person. The next person, all the way to, oh, someone is telling me we have Kipchoge. All right, my bad. Yes, you take and you give it to the next person, and the next person now has to complete the race, and we win. All right. Now, neural networks, we look at it like, let's just think like it is passing information from one person to the next, all the way until the end. Whatever happens in between here, I will come and explain in the subsequent slides, but that is how the neuron works. The neuron works by getting sensors through some receptors. And for instance, if you pinch your hand, how will your brain know that, okay, this pinch is someone joking with you, but this pinch, remove your hand because you're getting hurt, yeah? How does your brain know that, okay, it's time to remove your hand? So the receptors pass this message, and it's like an interconnection between one neuron to another. The message is passing, and then there is a threshold in which when it surpasses that threshold, that's the time you need to act. So we will talk about this briefly because this one was about chatbots. So, and in particular, the simplest way, my objective here is to enable you guys know that this is a monster, yes, but within your skills that you've acquired, you can actually build something very basic and grow to the level where you actually are using these complex, techniques. So I'm explaining the complex techniques, and then the objective of today's session is actually to break it down and answer the question, where do I start from? I know that's the question where most of you guys are, because you want to know, where do I start from? And you will get, hopefully you will get the answer at the end of this session. So that is deep learning, neural networks, okay? NLP. NLP is a concept of how to manipulate text, how to get and derive meaning out of text, yeah? Text analytics. So there are certain terms that fall within NLP, like breaking those text, the words in a sentence into pieces, trying to understand the grammar and syntax of that text, because whenever we are speaking, or any language normally has certain syntax, it has certain semantics, yeah? So how do we then try and understand the semantics and the syntax of a specific language and try and teach the machine about this syntax, yeah? Because we are trying to teach a machine basically how to respond to human language. How do we do that, all right? So if it is text, then we are using NLP, where NLP has certain capabilities. First of all is to break the data and identify which words in this sentence are meaningless, which words in this sentence have meaning, and are the spellings correct? Are they in the root form? So each of those things are surrounded by, and they are all under the umbrella of NLP. Okay, so that is a complete topic on its own, but it's a very, very interesting topic. I know some of you guys have come across tokenization, lemmatization, spell checking, stemming, chunking. All these terms we come across when we study NLP, right? Thank God for deeplearning.ai, all these things are available in their courses. And if you're definitely interested, this is something that I strongly vouch for. Yeah, you have to commit and you have to purpose to gain and build your skills. Okay. Which general process? Okay. So you understand the background of the chatbot in terms of business requirements. You understand the metrics being measured. Now you're ready. It's like a farmer. I think it's Joseph who said he's also a farmer. Or was it Joseph? So I'm going to use Joseph as an example. So Joseph wakes up. Is it Joseph? Let me just confirm. I might be using a name that it's not Joseph. Joseph, was that you? Rose. Let me just confirm. I remember he spoke. Who spoke earlier and told us he was a farmer? Was it Joseph?
Yeah, if I'm not wrong.
Okay, yeah. So Joseph wakes up and prepares himself to go to a farmer. Now we are in a point where we've gotten an idea, but what do I do? It's similar to the question that I had asked a few minutes ago. Where do I start from, or what can I do? So some people normally go to the internet, how to build a chatbot. They get like 1,000 responses. They say, okay, oh my goodness. Now, out of this one, which one should I follow? you get into the first one, you try midway, you come across a term that leads you to another link, and then you end up in a web of exploration. And then you forget that you wanted to know the steps of building a bot. Just that. Now, today, I hope you'll get the answer. The first thing you need to do, define your goal. What is it that you want the chatbot to do? And we had I mentioned a few slides back of vertical chatbots and horizontal chatbots. Which one do you want? If it's a vertical chatbot, it means you need to restrict within a certain domain. And domain changes. If it's a chatbot for a supermarket, if it's a chatbot for a service industry, what is the domain? Okay? So, and write it down. Define a chatbot which will build a chatbot which would satisfactorily converse with customer of company X, Y, and Z, or of industry X, Y, and Z. Ontology. Now, this is normally the craziest part. It's crazy, it's very difficult, but it is a painful process that you have to go through. Yeah. So ontology is basically a repository of mapped conversations. You would call them mapped conversations. You have what the customer said, and you have what the customer support staff said. Yeah. So you need to look at this, and there are several ways of coming up with this approach. Ontology is just one of the approaches. Another approach would be you'd want to label your data. Yeah. So for instance, let me think of how to build an ontology or how to build that repo of your data. You scrap the data from Twitter, and then you want to build a chatbot. What do you want to do? If you had defined your goal in the first step, you will know what to do at this particular moment. So let's assume, and I want you guys to work with me. Let's assume we want to build a chatbot that is going to help us answer queries of flights availability, whether or not the flight I can actually reserve a seat, or I go ahead and make a book. I book the flight. So we go to Twitter and scrap conversation about such queries. Yeah. So some queries would have the from, to, and probably the amount. Some queries would have just inquiries. Some queries would have nothing to do with booking a flight. So all you have as of now is a set or a list of tweets by customers talking about a certain flight company. What are you going to do? If you approach, you don't have the answers from the support staff. There is someone who needs to mute. Rose, do you want to help me with that? Okay. All right. Okay. All right. Sorry for that. Now, what do you do after getting these tweets? So you've scrapped your data. If you had written the goal, so that is our goal, conversation, and this conversation we are refining it to, can we actually tell an answer whether the flight is available or not? That's the answer we are seeking. And we want to derive a chatbot from the list of conversation. So let's take scenario one, which is a happy path, what I'll call a happy path. We have everything in that tweet. And this tweet says, do we have a flight, do do you have a flight from Kisumu to Nairobi that charges between 2,500 shillings and 7,500 shillings as the maximum between today and say Tuesday. That is one tweet, and it's a happy path, as in it has everything. It's a conversation. So you go to Twitter and you're asking KQ, or you're asking an agency. That is an agency site. They are dealing with several flights. So you ask them, by the way, do you have a flight going from Kisumu to Nairobi? And the budget is say 2,500 shillings and 5,000 shillings, and available for travel between today and Tuesday. You have everything in one sentence. So if you are to build a chatbot that is going to answer that, you need to figure out a way, how do I check, first of all, if we have any destinations? And how do I know which of the destination provided is the from and which of the destination provided is the to? Has there been any mention of a budget? Like now, this guy, do they have, the person asking this question, do they have a budget, or they're just open-ended? They're comfortable. And have they defined a time span, the period within which they intend to fly? So the availability or lack of this information in the tweet would definitely determine the kind of response the chatbot gives. If the time period is missing and the rest are available, then the bot, instead of answering, would probably ask, by the way, do you mind telling us when you intend to travel? And then the customer provides that information. Same to the others. If any of the others is missing, or for instance, if all of that information is missing, then the bot needs to be aware for any answer similar to what has been asked. First of all, the bot needs to know that this is a booking flight inquiry, right? So that is the first thing the bot needs to know. What is this domain, or what is the context of it? So it needs to know that this is a booking flight inquiry. There might be other inquiries, like transfer. It could be cancellation. It could be lost handbag. Like now, I flied with KQ last week and I've lost my handbag. I'm following it. So the bot needs to be aware of what is the context of this discussion, or what is the subject of this discussion. So once it is aware of the discussion or the topic, then within each topic, it needs to find out what are some of this information that is necessary for me to give an appropriate answer. And one of it is the time, the date, the budget, the from location, and to the to location. Now you have a headache to derive this from these tweets. So that process, whichever process you choose, we will explore process in the subsequent slides. Whichever process you choose would be, in a way, you're creating or building the ontology that you're going to use to build your chatbot. All right? That is step number 2. Now, let's assume you're successful, you have an ontology, it's very clear. So the easiest one would be probably you labeled, or maybe you wrote a Python script to pass through all the tweets and check for this information. And as it runs, you're creating columns. You're depositing this information in a CSV file, for instance, in a CSV file. And in that CSV file, you've created the text. This is the text. And then you've created additional columns. And the first column would be, say, the subject, which is the topic. Is it book flighting inquiry? And then the next column would be like amount. The next column would be from. The next column would be to. The next column would be, say, the period. Yeah. So if you pass that tweet and you find that you write a script that passes through that tweet and you find that the amount is not there, the column remains blank. If you find that the from is not there, the column remains blank. But that is a rudimentary approach. though it is achievable and it gives you actually control, it is achievable to write the script and populate an Excel sheet and then use that Excel sheet to start your work. So at least you have an idea of the approach. We started from completely text that we are wondering what do we do with it. Now, assuming you've generated your Excel sheet, now your data is in Excel sheet. It's no longer, you've scrapped it, it's an Excel sheet and it has all those commands. You need to start processing this in terms of NLP, using NLP, derive intent. Like now you're pre-processing it to be understood by a machine learning algorithm, okay? So the techniques, the first thing you need to be comfortable with is NLP tools. So what does it mean to tokenize? What does it mean to stem? What does it mean to lematize? And not only what it means, but how to do it, okay? I have a notebook that we will go through at the end of this session, and you will get a feel of the entire journey that I'm explaining to you guys. Okay, so don't worry. So the third step is pre-processing using NLTK library or any other library that you might feel that you are comfortable with. We have Stanford NLP, and we have TextBlob. TextBlob is still within NLP. It's an NLTK toolkit, but it helps you achieve some of these things you're talking about. All right. So we also have like Spacey. So the use of one against the other, you need to be aware of some of the benefits. You need to be aware of why should I use this and not this, and what is the strength of using this, and what is the weakness of using this. Those are some of the things that would drive your decision, and the decision should be anchored on the two things, the metrics that we had discussed about previously. And the metrics should be driven by the business. Now, what you're looking at in front of you is a matrix of the types of chatbots that you can actually do that are contextual. You have retrieval chatbots and you have generative chatbots. So retrieval chatbots, as you see from the slide, on the x-axis you have retrieval and generative, on the y-axis you have closed and open. So when I say it is easiest, it is retrieval. It's retrieval because it's closed in the sense that it's within a certain domain. So you have control of the vocabulary. You have control, you have prior domain knowledge of the kind of environment you build in that chatbot. And to be honest, it's justified to say that actually it is easier. But it's only easier if you know how to do it using one of the available techniques, either deep learning or other techniques. I call them econometric techniques. So we will go through that in the coming slides. So if your skills are good, or if you develop skills that or technical skills that in any one of those areas, either deep learning or econometric, you will still be able to build a chatbot. Yeah, and if you compare the way you build a chatbot with any one of those, as compared to the other matrix, the other components in the matrix, you will come to the same conclusion that it is easy. So if you look at retrieval and open, according to this, it is completely impossible. And I agree, because retrieval means you're making reference to a certain source. Now, this source, do we have one, apart from Google, do we have one source that is aware of all the domains, all the vocabularies in this world? That is where the challenge comes in. Because some vocabularies are private. They are private to certain organizations. They are not available as much as we have Google. So for instance, if you wanted to Google, not even to Google. You wanted to talk about, you want to build a chatbot about salaries of all supermarket employees. The salary of supermarket employees is within the supermarket systems, and this system, they don't expose it outside. So while you can guess salary based on surveys you've done from people who do who work from supermarkets, it is not accurate, and you cannot use it to answer, to give an answer, a justifiable answer to someone who asks, what is the average salary of, or what is the salary of a bank teller? So it is impossible. That's the reason why I agree with this slide. And then we have generative, and we have general chatbot. So this chatbot, it's open-ended, but it asks general, not specific. It's just general for fun. Like now, general means information available in the public, like historical information, general conversation, social life, psychological games, that kind of stuff, general intelligence. So generative, general chatbot, things like Siri, those are general chatbots, yeah? But again, very few companies can go ahead and do something like that. Microsoft have their Cortana. They are able to do things like that. IBM Watson have quite a lot of off-the-shelf built frameworks. Intelligent bots, they are generative and they are closed. This is difficult, yeah, but it's possible. Yeah, I'll explain why it is possible, but you cannot use generative chatbots to do customer service. I'll explain that in a short while. Creating a corpus. A corpus consisting of input of context, conversation with prior sentences. So basically what this means is, depending on the approach that you take, the Excel sheet I mentioned a few slides ago it's what we can consider as a corpus. This is going to be our reference for the conversation, yeah? So one of those record is known as a document. So a corpus is a set of, or a collection of several documents. So if you look at that tweet, the first tweet on row 1 of that Excel sheet, our hypothetical Excel sheet that we scrapped information from Twitter, that first row is known as a document. Now that entire collection of tweets now becomes our corpus. All right. All right. Now there is an exercise. We have a corpus. We've done NLP on the corpus and on our data sets. Let me use. I don't know if I'm spelling it or pronouncing it correct or wrong. Some of these, excuse me, some of these words, they are not my mother tongue. So I might pronounce them the way I feel, and considering this is a public forum, I want to put a disclaimer. I'll try as much as possible to use words I'm comfortable with, because I can really mess myself up. Where I come from, some words like, we try to avoid words that start with S. So I'll try and do the same with some of these technical difficult words. But what I mean by that is, I'll try and use an alternate word to pass the same meaning. And the alternate word is our data set. You guys relate with data set. Simple, easy. All these things, corpus, just look at it like it's your set of data, and you get to do something with that data set. Now we've prepared it using natural language processing. We've created, we moved from the tweet to the Excel sheet. From the Excel sheet, we've now prepared it. I'll walk you through the notebook as we explain. So if you're not following, just understand there is a process where you prepare this. And the last one, just before we start our modeling, is a process where now you need, because machine can never understand text, we need to find a way of converting this text to something called vectors. Yeah, this is a representation of data in terms of zeros and ones. Yeah, can you represent the verbatim in terms of zeros and ones? Because machine understands zeros and ones. Now, I want to walk you through the process. Let's look at two sentences you scrubbed from Twitter. While someone was trying to book, they deviated with the chatbot from the booking and say, by the way, I like watching a movie. Ah, so you like watching a movie? Yes, and I enjoy watching a movie. Those are two statements mentioned by the same customer. I like watching a movie and I enjoy watching a movie. Now, step number one. The first thing you're going to do before you start doing vectorizing is to identify the vocabulary. The vocabulary is a set of unique words from your corpus. Now, the corpus is what we said. It's a list, a collection of documents. So you look at all those documents. What are these unique words? Yeah. So if there's repetition, like in this case, we have I like watching a movie and enjoy watching a movie. Through NLP, we did something called removal of stop words. So a word like I like watching a movie, the word does not add any meaning to that sentence. It does not add any value to that sentence. It just makes it, it just makes it easier as per the English structure or syntax or grammatical or the semantics of English. Yeah, I need to mute somebody. Excuse me. Sorry. Okay, that's better. All right. So what I was saying is we need to first identify the vocabulary. So there's something called stop words, and you need to identify them. There is a process using NLP that enables you to identify the stop words and remove them. So once we've removed them, we are left with a vocabulary. So that vocabulary is a set of words present in, unique words present in your corpus. So your entire corpus or corpora or dataset, all of them, you've put them and you've put them in both the X or horizontally and vertically. Okay, so the manual process of coming up with the vector is the presence of absence of a certain word in your corpora. So for instance, I like watching a movie. The first index, 1, watching is present in both, movie is present in both, but the word enjoy is only present in 1, it's absent in I like watching a movie. Yeah. And then there is when you're checking out the second representation, so I hope you can see where I'm pointing. The first, this 0, 1, 1, 1 is for the first sentence. Yeah. And the next one is for the second sentence. So the second sentence, you notice it doesn't have when it has enjoy, you have a 1 here. Movie, yes, 1. Watching, yes. It doesn't have like. Okay. So the process of creating the presence or absence of a word based on the unique set of words in your data set is a process which is called vectorization. So when you're dealing with a lot of data, you can definitely not do it manually the way I've just explained it. So we have tools that helps you do that. And depending on the approach within which you use, either deep learning or econometrics, you will have to come up with the vector, a vector representation of the words that you want to pass to the machine. All right. Okay. So there are classes that you actually take, and there are a lot of tutorials about that. This is just an explanation of what you're going to be walking through, and just get an understanding of there is need to convert words to convert those words into vectors, and vectors get to be understood by the machine. This approach is called bag of words. So the CBOW is continuous bag of words. So you're looking at the unique words and putting them all together, and now trying to come up with all those representation, the presence or lack of, based on the words that you have. All right. Now, what happens with the continuous bag of words? It's using a specific target word to try and predict the words around it. Yeah. So if we go back to the previous slide, if this is the target word, which is the most likely word that will come next after the word I? Yeah. So this is a process, and continuous bag of words. It's I would say it's a neural network with 3 layers. The first layer, input vector layer, is where you pass through the vector that you've come up with. And in this case, it's this vector. Now you see it's 1s and 0s. And then the hidden layers are now the neurons making those decisions based on specific thresholds, or what I would call, for those guys who've gone through this, there's something called activation function. But for those guys who are completely new to neural networks and are in this forum, don't be scared by this. Basically, what you need to understand is there is a way that the target word is used to predict the surrounding words. And that way is called continuous bag of words. And what you're seeing on your screen is a representation of it using as a neural net. Okay. When you take courses, when you're doing courses or you're doing own personal study, you'll come across these words, and they'll make more sense. Right now, I hope and believe that up to this point we are together. You understand how we moved from Twitter to Excel sheets to now the vector. And now for the vector, we have a specific word. And for instance, this word is I. So this word here is I. It's a vector representation. What is the most likely surrounding words? Is it going to be like? Is it going to be watching? Is it going to be movie? Is it going to enjoy? So based on this output, each of these are given probability scores. So if like has a high probability score, then it becomes the next word. So you have an idea of how this is doing, how this is working out. Okay. Now, there are 2 things that normally happen when you're doing vectorization using one of the techniques is called word-to-vec. The problem with a continuous, before we go to word-to-vec, the problem with the bag of words, yeah, bag of words does not maintain states. Like it completely forgets. It doesn't have capability of relating the previous word with the previous one, yeah. And there's a specific term for that. Word-to-vec addresses that issue, where the first thing is it uses surrounding words to predict a target word, and then the target word is used to predict the surrounding words. And I think the explanation I gave previously might have conflicted. Let me just correct it. In continuous bag of words, the input vector is you're using, or it's the input vector generates targets, like now identified the target words, yeah, and then from the target word, sorry, I identify the surrounding words, and then from the surrounded words, the target vector is, the target word is predicted, yeah. So like I explained here, if the probability score is if the probability score here is for like is high, then the target word become like, okay. So if you look at the surrounding words and identify the target word, like here, once the target word is identified, use that target word to predict the next surrounding words. So this thing is a combination, a high-level understanding of how Word2Vec works. Word2Vec technique is one way of converting word to vectors. So the first way we've covered so far is bag of words. The second way we are looking at is Word2Vec. Word2Vec has two things, a combination of continuous bag of words and another one called skipgram. Skipgram is when you're using the target words to predict the surrounding words. So that is a process that we need to do immediately before we start doing modeling. Now we have our text that we scrapped from Twitter as vectors, and we have used Word2Vec. We need to start teaching our bots how to respond to questions. We have deep learning techniques, and this is generative, yeah. So deep learning technique, there is a TensorFlow sec-to-sec. You could go and read more about it, but ideally, we have two neural networks using something called LSTM. One of them encoder, and another one is considered decoder. So the encoder's purpose is to receive the vectors, and the decoder's purpose is to generate the vectors based on the anticipated output, what it learns. So in the process, the learning happens over here, and then an output is generated, okay? So there's so much that happens, and it is, there's so much that happens. Okay, if you're on mute, if you're not mute, please mute. All right. Okay, we have encoder and decoder, and there is a lot that is happening on the sec-to-sec model, but there are ways of building this model using TensorFlow, and you will see that at the end of that exercise, it actually generates an output, yeah? So this output, more often than not, and this brings me to the reason as to why generative models are not ideal, but I'll mention that in the next slide. The things that we need to learn with generative models is what I had mentioned earlier. There is a need of putting all the context, and like you're preparing this data and put it What just happened? Are we still together? Rose, could you kindly confirm?
Good question.
Hello, Robert. We had lost you a little bit.
Oh, okay, okay, all right. For how long?
When you started this slide, I think, yeah.
Oh, all right, all right. I don't know what happened. I just got
Oh,
disconnected, but now it's good. You're back.
okay.
All right. So I was saying the first thing that you need to do is to build contextual mappings, and this contextual mappings is I would relate it to how you pick a document and map it to any of the labels that you created. But in this case, you're mapping conversation to conversation. If you want to do generative, so you're looking at the query that came from the customer and the response that it was given by the customer care agent. You want to train the bot that you want to build a sec-to-sec model that would understand that you can actually generate a response by looking at two conversations. So that contextual mapping needs to be done. Another thing is you need to build a vocabulary and define this. Main reason being, one thing with generative is it looks at the size of the inputs or the message, in this case, the tweet. So with generative, if you have longer text, like it is normally in customer support, there are some texts that are longer because maybe the customer is wordy. There are some texts that are very, very short. So when you're building a generative chatbot, you need to take into consideration the size or the anticipated size of that text. Yeah. So you need to look at that text, and if you must have certain things like let me say question mark into it, some other stuff, then you need to either pad. There's something called padding using some special tokens. So those are the things that needs to happen when building a generative chatbot. Okay. And there's so many techniques of, I've just mentioned one, sec-to-sec for TensorFlow. But for customer service chatbot, you wouldn't go that route for the various reasons. Generative chatbot can tell you anything. It can generate anything, something that you will not even be understood by a human being. A generative chatbot could even insult a customer. So for instance, by any chance, there was a customer or there's a set of customers who are customer care agents. If there is a set of customer care agents who are a bit straight, like, dude, I've answered your question, let's move on, or do this with some cold hearts. You know, we have such scenarios. So if by any chance there was a customer care agent responded to a customer in that text, then the bot will learn, and the bot will generate a response, and it will adopt the connotations and the feeling within which it learned. So if there was an insult in that, the bot will insult. If it's meaning that we have no control of how the bot does its stuff. The only way we can control it is during the context mapping process. So we need to make sure that first, the context mapping is accurate. Second, we need to do a lot of statistical analysis on each of those texts. And then third, we need to make sure that the verbatims or the vocabulary are not misplaced, and also put into consideration the spacing or the length of the message. So there's a lot of work, okay? And then another thing about generative is it's incoherent. At times, the responses do not make sense. It just puts together a bunch of words, and then you really cannot make sense out of whatever it says. That is a possibility. So for it to be successful, it needs to have a lot of data, and the contextual mapping needs to, according to my opinion, it needs to go through a rigorous QA process where we have human beings looking at this data and making sure that there is nothing that the answers given by the customer care agents were actually accurate, and there is no abusive language, there is no as in it's up to a certain level, all right? Now, any company that would want to test this, yeah, and take it to production would should put up a disclaimer that this is for test and they're welcoming customers to test. This is not for use because of the anticipated, the outcome of a generative bot is not always clear, and this is still more on research, and a lot of work is being done. Most chatbots are built using econometric techniques. Basically, this is just a just word to mean mathematics and statistics lumped together to make to mine that data and make certain decisions. Right? The normal algorithms that we've all come across, naive Bayes, support vector classifiers, random forests, all those algorithms, they now come to picture. So I know most of you guys find deep learning intense, and it is intense, but deep learning has very, very good capabilities. And even in deep learning, you can still use it to do classification without using sec-to-sec or without using generative. So you could build a neural network that is a classifier and end up with very, very good performance. So it has benefits. So when I talk about econometric techniques, I'm not excluding by any means, I'm not excluding deep learning classifiers. Those are also included in this discussion, all right? Okay, the reality. I think I'm almost done with my slides, and then we can go to Jupyter. Before we go to Jupyter, I think I'll take another feedback to just get a feel of how the class is so far. So the reality, what business expects. The reality is this. You're employed as an NLP engineer, you're employed to build a chatbot, or you're a consultant building a chatbot. You'll be prepared to spend sleepless nights because you will be judged not by the score, not by the F1 score, not by the accuracy score, not by the confusion matrix. You're going to be judged by what customers say. And that is, the judgment comes from NPS. While there's a correlation between your score and F1 score to the NPS, it's not always a direct one. It's not always like if your accuracy score is high, it automatically means that your NPS will go high because of other factors and capabilities of how you implement that chatbot. So for instance, if you wanted to, you're building a shopping, if you're building a shopping chatbot, if you don't have a feature of checkout, your NPS is most likely to go down because you're lengthening the process within which the customer gets their goods. But if you integrate the checkout where they can check out automatically using M-Pesa, so once they confirm everything they want, they just press a button or they say, yes, please go ahead and send me the SDK for me to enter my password. Excuse me. And then they make the payment and they say, your order will be delivered in, say, tops 30 minutes. One person who implements that integration of checkout would enjoy, is most likely to have higher NPS score as compared to someone who built a model with 80% plus ability to derive intent of a text. The model would work, but the judgment will not be based on the model accuracy. The judgment is going to be based on the cumulative effort and the cumulative integration requirements of how the chatbot is delivered to the customer. So when building a chatbot, you need to have something called journey maps. Model is just one of the components. So that is the reality. So you can be a very, very good machine learning engineer, but if you do not deliver this model to the expectation of the customer, your effort and the appreciation of what you've done will disappear. and it will take time for it to come out. So as an ML engineer, it is upon you to make sure that all the pieces fits in together and the desired value is achieved, okay? And this is controlled by journey maps. So you look at a customer's journey map, what do they want to do, what, how many steps should they do it with, and what is involved in between, and what is the success story, okay? So that is the reality. So focusing on only modeling is just a piece to the big game, yeah? Now, another reality is, like I said, quick turnaround time. The business expects results, almost immediate, and it needs constant delivery. So we've covered deep learning. We've covered econometrics, or I've mentioned econometric techniques. Depending on the duration available, what is the best approach to satisfy the needs and the desires of the business, while at the same time acquiring your skills, and at the same time experimenting with other techniques like deep learning techniques, building a neural network to solve the same problem? How then do you approach this problem? You want to balance between business and technical skills and technical skills and achieving the objective, all right? The other reality is we have few machine learning engineers. Some have little or no experience. And machine learning is an art and a science, something that business don't understand. So the fact that it's an art and a science, it means it takes time. It's like you're in the laboratory. You need to like test a lot of things before coming up with a conclusion, especially when it comes to text analytics. So you need to look at the verbatims, you need to look at the words, you need to derive a lot of similarities within those words. You need to spend a lot of time, okay? And the fact of the matter is patience is needed. Guy, yes, Guy, please go ahead. There's a question. Guy, you're on mute. Yes, go ahead. Hello? You raised your hand. Okay, let me see. It's probably chat something. Okay, all right, no problem. He raised it by mistake. All right. Okay, so the reality of the matter is patience is needed, and we need to get these skills. And for you guys as a machine learning engineers, beginners, how then do you make sure you balance and business actually appreciates your efforts and also see progress in whatever it is you do? From where do you start? All right. The use of econometric techniques. So basically, the models that we build in class or session when you're learning from either your own research or you've attended a course, either you've attended a deep learning AI course, those models that you build, you can actually start from that and build a model out of it and fit in the pieces using a workflow and deliver the model as normal classifiers, integrate them into a workflow, and then, yeah, push your model to production. I'd mentioned some of these things, but let's revisit them. It's similar to econometric techniques. Number one, you need to label your data set. Number two, you need to pre-process that data. Pre-processing that data is like now using NLP techniques to prepare it. And the objective of this preparation is to make it converted to vectors. And we saw that we've covered two, though there are so many. The first one was bag of words. The second one was word to vec, of how to convert those words into vectors. And then we need to model and choose the best approach. So when modeling, you pick an algorithm and use it to, you expose that algorithm to your data, and then you use it to generate a certain model that understands your data. So you could use several algorithms like now random forests, naive Bayes, support vector classifiers. All these algorithms you need to understand. You could test like 3 or 4 or 5, and then you create a pipeline within which you generate a portable model into something called a PKL file. A PKL file is just like an exe file. After building a software, you deliver it to a customer using an exe file, and you install it on their computer. Slightly different. When you have it as a pickle file, you can expose it through REST API. So REST API is just, let me look at it this way. For the sake of guys who are not so techy, look at it like it's a door that if you want to get answers, you go through that door. And for instance, you have Facebook. Facebook is someone who wants to get answers from your chatbot. So Facebook needs to go through this door and get the answers. So for Facebook to get through this door, it needs to have the key to the door. And the key, when you're building that API, application programming interface, when you're building it, you have options to make it open, like it's just an open door. Anyone can walk in and walk out. Or you can protect it. You can protect it using username and password, or using something called tokens. So the way you build that API depends on what you want. Yeah, the most recommended one is to protect the API using either token or username and password. When you're using username and password, then the protocol you use shouldn't be HTTP. It should be HTTPS. All these things you need to be familiar with because they contribute to our starting point where we looked at what does the business really want. Okay. So once you deploy your model, once you have your model as a pickle file, you can expose it so that anyone with that the key to the door can open the door and ask the bot a query. So anyone else who doesn't have the key will never access it. So the beauty of packaging it and giving it a door, it means you can have people from Facebook use your chatbot. You can have people from Twitter use your chatbot. You can have people on SMS use your chatbot. All you need to do is to give them the key. And there is a way of giving them the key. This is a language of programmers. So if you don't have that skill, then you need to acquire it, or you need to focus on just building models and partner with programmers on how they can enable your model be accessed through the door using a key, all right? Now we will interpret metrics. For this class, I was not focused on performance of the model. So the accuracy and the F1 score is poor because the data is not substantial. I purposely did this. Actually, I wasn't prepared for this presentation as much as it's been on my radar for the longest time, I think a week now. But the main reason being I've been overwhelmed in the office. So some of these things I did them in a rush, the last minute. Here in Kenya, I don't know about the other countries. Here in Kenya, most people do things last minute. But I hope that what I've done at least has made sense to you guys. And you'll see the notebook, and it has given you the foundations or the fundamental or the journey of you starting your program. If you're intending to do a course in NLP, now you have an idea of what to expect. You have an idea of what you need to do from the business angle as well as from the technical angle. You have a good base within which to make a decision. So you can make a decision of either follow like now, just go out there, identify a project, NLP project, and you start doing it. Or the first thing, you can enroll for a course, sharpen, team up with a group of people, and make this thing work. So the metrics interpretation in the notebook has nothing to do with performance or quality. That is a disclaimer. Now, number 8, where we implement the response. implementing response generation is dependent on so many things. I need to mute somebody. Okay. All right, number 8, implementing the response depends on quite a lot of things, not just the model that you built. Like I said, the model that you built can have the best accuracy and F1 score, but it might fail the test of business. And the test of business, they look at 2 things. Is the NPS growing? And they use that to further drill down based on the metrics that I shared with you guys in previous slides. And the second thing it looks at is the chatbot working? Out of the queries that the customers are asking, is it 50-50 or is it 80-20? Is the chatbot answering 80% of the queries that are coming through on a day-on-day basis? So implementing a response is a culmination of all those factors and largely implemented through logic that can be developed and built within a framework. The framework I recommend is one called Django framework, though there are others that are also capable of doing the same. Flask, that is if you're deploying when you're using Python. All right, that was the last slide. Quite a mouthful. Before we go to the last session, for Jupyter Notebook, once again, I just opened for 2-3 comments. If we are still together, if you feel like saying something, if you feel like asking a question, just you could shoot. I'm opening this for you guys. All right. This is where I now pick, and I'm going to pick. And don't. You know, one thing with Zoom is you can't see faces. You can't. You don't know if someone is cooking outside and they are on your chat. So you can call a name and someone maybe is cooking lunch. We are almost in lunch. Oh, Abdurrahman has confirmed all is good. You could also just type, if you're shy of speaking, you could just type on the chat box. For those guys who really feel like saying 1 or 2 things, I welcome you. I will pick, I need someone to talk, and I'm going to pick Gilson. Gilson, are you with us? I'm going to pick 3. Okay. All right. Oops. All right. But something must have happened. All right. Let me pick someone else. Rohi? Rohi? All right, let me come closer home. I picked those ones. I think maybe it's because of internet. I picked those names because I suspect they're not from Kenya. Because of one reason or another, they might not be able to talk. But I would appreciate if they're listening. It would be good to hear their thoughts. I'll pick Abigail. Abigail? I told you guys I'm looking for 3 people. So if I don't get 3 people, we will continue like this, and Ross is not going to close the session. I need 3 people to talk. While guys can also chat on chat. That would be good. Abigail or Erimu? Ah, good. Abigail has responded. All right. So I think it's the talking. Caroline? All right, I can see a question. Caroline, would you want to say something before I respond to this question? Okay. All right. Let me respond to this question. Deep learning, machine learning, and NLP. Do we apply all of them in our models? Okay. For NLP, when you're doing a model for chatbot, NLP is a must because you need the ways of deriving the semantics of the text data. You want to do a couple of manipulation on that text and try and understand a bit more and prepare it for the algorithm that you're going to choose. So that is a must. So machine learning and deep learning, you could choose to do one or both, solving the same problem. So the first thing you could do is build a machine learning model using one of the algorithms. Say, for instance, you can use support vector classifier algorithm to build a model and come up with results, and then use the same data set and build a neural net to do the same classification problem. And then you could see, is the neural net classifier performing better than the machine learning algorithm, say support vector classifier algorithm. So it's dependent on the approach that you want to use. That question came from Bill. I'm not so sure if that answers your question, Bill. That answers it. All right, perfect. Okay. All right.
So there's another question from Emmanuel.
Yes, Zachary.
Oh, so I can see another question from Emmanuel asking if will we have some presentation materials after this session? Yes, definitely, Emmanuel. So Rose will share the slides after Robert has shared them with her, and also we have a recording of the session, so the recording will also be shared. Yeah.
Awesome. Thank you, Zaki.
Okay.
Awesome.
Hello.
Yes, Timothy.
There was a point where you said, like, once we have created the model, we have gotten an API. What are we to use if the authentication we are using tokens, and what are we to use if we are using username and Gmail?
Oh, okay. Yes. I remember. I mentioned that if you're using username and password, it is just recommended for security purposes. If you're using username and password to protect your REST API, then the protocol that you use should be HTTPS, not HTTP. So when someone wants, it's like now the protocol is the means within which it's like the road to your door. It's the road to your door. So the common road being used is normally HTTP, meaning the way you can access someone's website. So you use the protocol HTTP. But for APIs, you can use HTTPS if you're using username and password. But if you use token, it really doesn't matter because token is most preferred and mostly used in that cases. Not everyone can afford HTTPS, but there is need to protect your REST API, so you use tokens. Does that answer your question, Timo?
Yes, thanks.
Karibu.
Okay. Hello, Rob.
Hi, Abdullah.
Okay, you mentioned that we can use ensemble learning by combining several models, right?
Yes.
Okay, can you please, talk more about how exactly can we do ensemble learning in this scenario?
All right, in this scenario, it would be more of design where you cluster. You could choose your clustering a batch of algorithm. The first approach would be you cluster a batch of algorithms, say 4 of them, different algorithms. Say support vector classifier, naive Bayes, random forest, and logistic regression, for instance, because the classification problem. So when you cluster them, you push the message to each one of them at the same time. And this is implemented from a workflow. Remember the dialogue management? diagram that I shared earlier in previous slides. So you push all this, and each one of them makes a prediction at the same time. And then you do a weightage based on the prediction that needs to be made, and make and pick the output. Now, in the context of a chatbot, there are several decisions that needs to be made. For instance, I'm thinking of a situation where if, let's go back to the example of booking a flight. So when you're booking a flight, there are certain things that you need. So the first thing you need to do is to find out if you have all the information. Now, the first thing that you'd want to know is the subject or the topic of this message. So it needs to be a prediction, yeah? So it needs to be a prediction. This message is to what percentage a flight cancellation, for instance. So that message, you push it to all the 3 or 4 models, and then they each make a prediction, and then you derive a weightage. Like now, derive a heuristic mean of coming up with a probability comparison across all them, or across all the models. The one that has the highest score is the one that now takes it to the next level. Okay. So remember, the first layer is a batch of algorithms put together making prediction at the same time. Another approach would be you put them sequential, depending on the workflow that needs to be executed. So depending on the level of or rather, depending on the time where a prediction is needed. So the first prediction would probably to determine the subject, yeah? And then the next prediction would be, if you want to make your chatbot multilingual, for instance, you might have another model that is just exclusively for making language predictions. So when you build that language prediction, you have an option of, in the next batch, you also use a set of algorithms, but for this main purpose, they are predicting language. So as you execute your workflow, while moving to deriving or generating the response that needs to be given, you're executing like hierarchy of sets of models, and the response is finally determined. The output of the model is finally determined. So you might have that, okay, this is the topic, this is the most likely topic, and this is the most likely language. So based on these two, you now write code, or you write functions to go and retrieve the most appropriate answer. And at the end of it, when you're doing retrieval, when you're pulling down the response, yeah, you have 2 options again. The first option is let the retrieval be specific, or let the retrieval be predictive again. So when if you make it specific, it means you've gotten the language, and you're going to rely on the specific output. But if you make it predictive, now it goes further and checks from this language and this output from the model, we have, say, like 10 possible responses. Yeah, so you have 10 possible responses that you can actually give to an agent. You can actually generate and give back. So if you decide to make that a predictive one, then you will need to do another model that determines that final output, which it exactly needs to be responded, to be sent back to the customer. So it depends again on how you want to implement this and how you feel it is effective. Yeah, and you could also even plug in a combination of, since there are several hierarchies of prediction points, you could use both econometric and neural nets within the same workflow, but for specific tasks. So, and that is why I said earlier on, machine learning is both an art and a science. So art in terms of designing how you want it to work, and picking algorithms that are very good in specific tasks, and then generating the response. I'm not so sure if that gives you an answer.
Yeah, thank you. That makes it very clear.
All right, okay. Any other question? Before we jump to, I know there is another session for question, so I'll jump into the notebooks. But if there's someone who wants to say anything, you're allowed to say. Comment, question, going once, going twice. We move on. Good stuff. All right. Now, let me see. Let me minimize this. All right. Okay. Let me. I'm just going to have to. That is the end of our slide. I'm going to start sharing the notebook. It's not so long, so we'll just skim through it quickly. Are you guys able to see my screen? I think I'll just increase this. Anyone to confirm?
Yeah, sure. We'll see.
Oh, okay. All right. Perfect. Roy has asked if I would share the notebooks. Of course, yes, I will. Immediately after this, I think I'll make everything available to Rose, and Rose will send it through together with the video as well as the presentation. So you will access everything that we've gone through: the video, the notebook, and the presentation. Okay.
The main objective is to make aware people. We have university students who have no knowledge about AI because in their school it's structured using the long time ago like details. Like when I started off doing my course, IT, I was being taught Visual Basic when people are still advancing in Python. So the industrial revolution is already here. Big data is already here. People are actually looking for data scientists till now. And the main aim for this program is to spread the awareness and also equip you guys with skills and resources and also connections. So maybe Wanjiku might need an internship and Didi can have, like, since you're in the same team and you have interacted, she might have connections with people who are looking for people with internship and stuff. Like in our other group, there's someone who's looking for someone to intern at I&M. You see, you know, someone can leverage. There's in the other group also, there's someone who is starting a startup. And we are able to connect that person with some Ethiopian guy who also deals with startups. So it's more of building connections among each other in Kenya and also creating job opportunities while interacting as a space, as a community in AI. So the future we see is we are curating a scorecard that will enable guys. A scorecard is like a resume, but it's structured like it has leadership modules. So in case in a resume or in a job application, they want someone with teamwork skills and stuff, you can just list there, you attended this discussion for Alliance for AI. Maybe this is the scorecard. You can check or you can verify if it's worthwhile or something like that. So it's more like creating opportunities. We are not a LMS, which is like Udacity course. We are more of trying to connect people with skills together. Like if you are someone who has business skills, you can connect with someone with data skills and you can create something worthwhile. So I don't know if I've answered your question about the future of AI or the future of the industrial revolution with Alliance for AI. Have I answered you, Anjiko?
I think she's on mute.
Wanjiku, can you hear me?
I think she's on mute.
Okay, so I don't know.
Yeah.
Didi, can you hear me, Kerubo?
Yeah, I can hear you.
I don't know if I've answered her question. I'm not
I
sure.
believe we have, I don't know.
Okay, thank you, Mugo. So if you have any other question, you can please for them on the email, on my email at rose@allianceforai.org. And for the session, I'm going to have a detailed report for you guys, because I don't know if you have questions on the AI narrative and why we are trying to make people aware of AI in Africa and why it's important before we are colonized the second time. And this time it might be even worse, because when AI comes and take over, and they'll be creating opportunities for their people in US, and will be I don't know what we'll be doing actually, maybe cleaning the machines or
Okay.
I'm so sorry, I have to attend a different meeting. So I'll send a feedback form. You can share your views on it and get us to know any more questions that you have, and then we'll answer them via email or via the Slack group. So please watch out for the email. I'm sorry I have to leave urgently, but I hope you have learned something.
Okay.
You are up for Wednesday or Friday sessions. That will be okay. We have a team, our team there, who are really engaged
Hello?
into the content and the discussion, and also have started sharing opportunities and links, which I'll also attach to the document. So
Hello, Rose.
watch out for that. A minute. I'm sorry, I'm being called to the meeting. Hello. Thank you guys for joining. Yes?
I think
Please
you've been listening
mute
to the conversation.
Oh my God, please mute me. I had two meetings at the same time. Azakia was,
So
I'm sorry.
I got a bit confused, no problem. I got a bit confused. So we were all
really thought
listening
I
to
muted. Oh God,
There is no
I'm so
problem.
sorry.
There is no problem. This happens. So we were all listening, and I was wondering, okay, but I figured that they, at some point that you must have been involved in 2 meetings. So I think guys have been very, very patient, but I'm so sure guys have understood. It's good that we are now back on track. We are almost wrapping up. I think I had up to midday, yes? So I don't want to eat into the QA time for people. So I'll just wrap up the Jupyter Notebook, and then we immediately go to QA. Timo, I can see you are asking about Slack. I'll leave that to Rose to wrap it up at the end of this meeting. And she might want to tell us which drugs she's on. It looks like her coffee today was very conk. Rose, don't worry, it happens. But guys have been very, very patient. All right, let's go back to the notebook. The first thing, remember we mentioned we need to find a way of extracting certain elements in text, and I gave instances of the from, the to. In the case of someone who wants to build a chatbot that books flights on behalf of people, like it assists you book flights. So that you need to derive a way of extracting that information. That process is called named entity recognition. And there is a tool or library similar to NLTK called Spacey. So Spacey, you can also use Spacey to do other things like tokenization, lemmatization, all those things that we mentioned earlier on. But for this particular case, I want us to see how to use Spacey to extract those entities. So entities are things like the names of people, the amount. If you want to fetch an amount from text, how do you do it? You want to fetch specific places, how do you do it? Then Spacey library is the library to use. So the first cell is importing the library. Because I'll share this notebook, I won't spend so much time in it unless someone has a specific question. Yes, someone said something. I won't spend so much time in it. Hello? Okay, I think that was an echo. Okay. Rose?
Please mute me. Yeah, please mute
right.
the Pi and AI ambassador.
Okay. All right, let me do that in a short while. Okay. Okay, this is strange because I'm not able to mute you, Rose. All right, I'm not able to mute you, Rose. Okay, then I think now I've been able to. All right. So I was saying, since I'm going to share this notebook, I'm going to share this notebook with everyone. I'll just skim through the notebook and you guys will have a chance to go through it. So the libraries that we import is pandas, numpy, NLTK to tokenize. We are dealing with, if you're dealing with tweets, you use tweet tokenizer. It makes life a bit easier in terms of data cleaning. We use Spacey, and the Spacey has predetermined like models that already exist for you to get started in terms of recognizing specific entities. So you need to import that library, and then you need to create an instance of that model, and we call it a Spacey NLP. Now, the way Spacey works, it's trained using mini batch and compounding. These are things that you will learn either in your certification or class, but it's a way of training the model on how to extract and identify entities, especially when you want to create custom entities. So text normally has, you might want to extract specific entities from text, and Spacey enables you to generate custom entities that are not from any of the predefined models. So if your industry or if your company has specific terminologies, excuse me, or specific, for instance, you're doing a chatbot and someone says, I want 2 loaves of bread and a packet of milk. You might want to create, while those are nouns, you might want to also create them and identify them as entities and extract them and try and figure out how much is 2 packets, or even ask them which brand of bread do you want, or which do you want Tuzo? Okay, for the sake of the guys, our international brothers and sisters, we have several brands of milk and bread. So one of them is Tuzo, Brookside, there are quite a number. So you might want to derive and create your own custom entities, and Spacey enables you to do that, right? So Beautiful Soap is one that helps you in data cleaning, basically handling HTML data. So you might want to use and explore Beautiful Soap as well. And then I had mentioned about vectorization. There is a TF-IDF vectorizer. It's important to understand what each one of them does, but these are some of the ways, the libraries from sklearn that you can use to convert word to vectors, as we have covered previously. And then a pipeline is like now combining the vector and together with, it's basically the simplest way of generating a pipeline and embedding all those solutions into one, embedding a model into one in readiness for you to pickle it. One versus rest is where you're trying to achieve balance, and if especially you're doing multi-class problem, several classes, and you want to ensure that you've achieved, it's a strategy within which to achieve balance. So you look at one class against the rest. So ideally you have quote unquote 2 classes, but it iterates, yeah? That is used within support vector classification. So the algorithm used in this notebook is called linear SVC. Train test split is how you split your data into training and testing. And then these are the metrics. These are some of the metrics that you will use. Classification report, accuracy score, precision score, recall score, F1 score, confusion matrix. There is a good understanding of, you need to have a good understanding of how to report how your model works. And these are some of the metrics you'd use. And then joblib library is what now enables you to pickle a file and create that pickle file. Now, once you create that pickle file, you can actually now expose it via a REST endpoint and enable people to use it, right? Okay, so that is the importing library. This is just for purposes, if you're dealing with huge amounts of data, you might want to set up your pandas or a Jupyter Notebook to view more records. There are instances where when the records are so many, it's like continuation. You don't get to see all the records. So if you want to change that and enable you to see the number of columns and maximum rows, that is how you do it. This is where now you import the data set. So I simulated searches. I got data from Kaggle and then simulated for the purposes of illustrating Spacey, how Spacey works. So this data set from Kaggle is a data set that has search strings from how people search cheap flights. So I narrowed down to specific columns, the search string and the action ID. So I looked at an action ID is like something that has been stored in the database that you might want to retrieve, yeah, depending on now the prediction that has been made. So that action ID tells you what the chatbot needs to do. Essentially, this is a very, very shortened version of the entire process. I think Abdiraham asked me this question, and I explained the various ways within which you can implement an ensemble of machine learning algorithms for you to deliver the appropriate generated response, or not generated response, the retrieved response. So when you're in the last leg after making the final prediction, how then do you retrieve that response? So in this data set, I've just assumed that this is the action ID within which we can use to extract that response from the database, okay? So NLP has pipes. These are just basically components that Spacey has pipes, which are components that enables you to achieve a certain task. So the first component, and the only component we are going to look at, is named entity recognition, NER. Yeah. So the way this works, I want to pull one of the messages from the search string. This is how you do it in pandas. And this is a string. So we want to see how this works as when you want to extract those documents, how simple it is to extract. But now using a predefined model, we are using a predefined model. So we could start by creating our own model, or we can start by using a predefined model. Again, the choice is up to the machine learning engineer. It depends on availability of data set. So in this case, we used a predefined model, which we imported above in the first cell that I had shared with you guys. So the model that we created, Spacey NLP, we created the instance. We need to create a document out of it, an NLP Spacey document. And the way to do it is just pass it as a parameter on that Spacey NLP object. And then loop through and check out which ones are extract which ones are entities and give them a label. So in this case, it identified Hong Kong is a place, it's a location. China is also a place, a location. So that is how easy it is to use SPACY to derive and extract specific entities from within text. So further reading and understanding of SPACY is really crucial for you guys to be able to build smart and better chatbots that actually do something, right? All right, so the next question would be, this one is just a way if you wanted to extract a specific component and use it from the NLP pipes. Now, the way SPACY works, it takes its training data in a certain format, and this is the format. And of interest is, let me just scroll down. Of interest here is we have the start of the string and the end of the string and the label. Okay, so you give it a string, and then using this, the next parameter is a dictionary, which starts from here. So this dictionary, first of all, it's a list, yeah? It's a list of tuples. So the first tuple here has a text string, and then it also has a dictionary. So the dictionary has a list of tuples, and the first tuple defines the start and the end of the string. Let me just scroll so that we see. Oops. Okay, let me explain using the last one. So we have a string here, and then the dictionary. The dictionary has a list of tuples. So in this list of tuples, the first tuple, you define the starting and the end of that string that you want to label, and then you label it as either an organization. So string starting from 24 to 29 is an organization. Yeah, you could, in the same string, you could have several entities. So for you to add additional entities, since this is a list of tuples, you just add a comma there, and you add another tuple, and then you define the start, the beginning of the sentence, and the beginning of the word, and the end of the word, and then you give it a label. It's as simple as that. Now, this process of generating the training data can be tedious if it is manual, but you can write actually a script or a Python script to loop through your Excel sheet and generate this kind of stuff. But it's a complex, advanced approach. There are certain tools that are used for labeling SPACY data, for SPACY training data. You could actually use those tools that have already been built. And yeah, that is how you prepare data for training SPACY. So in the event that you're done with training the data, you need to now label. If you want to add, remember if you want to add a value in the trained data, this is how you do it. We had extracted the named entity recognition of component from the SPACY NLP. Then you just use add label, and it's going to add it, right? Okay. This one is a way of using exclusively if you want to use the specific components. The SPACY has several components, so it's good to define within the pipeline which components do you want to use. So in this case, we have NER, WordPisa, and token to vec. Yeah, you could guess what they each do, but this is a pivot from within which, let it be your pivot from which you start learning these things. So at your own free time, either join a group that does this stuff and participate, or enroll into a course, or go out there, identify a project and do it and learn from them, all right? How do we train? Training the NER model. Wow, I've eaten into your time, you guys. Forgive me, I'm almost done. So this is how you train. The code is right there. It does quite a lot of stuff. And the training process, the objective is to reduce the cost function. Basically, the cost function is the difference between the predicted value and the actual value. So it keeps reducing, right? It keeps reducing until it finishes, and then this is where now you can give it a new text string and ask it to extract. So once it extracts, you can now implement the values you retrieved. Remember the list, it's a list of tuples. So you can actually look through that list and extract values from the tuple and make certain decisions out of them, yeah, and generate the response back to the customer, yeah. Now, because you're building a solution that you want to access via REST endpoint, you could save the model, and this is how to save the model. Now, this model, you can now load it later, yeah? Once you load it, you can now make predictions. And now, one thing to know is you could make prediction. As you make prediction, it could be updating the model at the same time, all right? So fridge can order in Flipkart. The output is there. A combination of that, together with your routing logic, and together with your modeling, which we're now starting here. So modeling, we talked about an LTK, where we import the NLTK. We do data cleaning. This is one function that does the data cleaning. And then we prepare the data. You will go through it. You can see from that, we can tokenize it. We can remove the stopwords. Yeah. We can do stemming. All these things are done in NLTK. And it's broad. It's very, very broad. Here is where I'm looping through and doing cleaning so that the most obvious one is to lower the case and remove any unwanted strings and characters, yeah, depending on what you want to do. And then the next one is encoding, yeah, because at the end of the day, you might want to use the mappings for the encoded values to do predictions. The next one is now the process of you're initializing a vectorizer, basically how you're going to create the vector that we spoke about. And then fit transform is now this text, it creates a vector, which we will call a sparse matrix. This is a matrix of ones and zeros. So once it does that, these are what we now know, we now understand as the features in machine learning. Now you have your features and you have your labels. You're ready to do a classification problem. You're ready to classify. Now, for you to classify, you need to initialize the algorithm you're going to use, and then you need to split your data. Yeah, that is the code that does the splitting. After splitting, you need to start training your data. When you train your data, you're predicting. You make the predictions. Now, out of the predictions that you make, you want to see how it performed. Now, that is a classification report. This model has a long way to go. It has an F1 score of 19%. Yeah, so it has a long way to go. All right, now you could check the accuracy. Accuracy is 18%, and then you could also do a confusion matrix. An understanding of what a confusion matrix does. So you can see from the confusion matrix, it actually tells you why it actually resonates with the F1 score. Yeah, so it's telling you this model is actually doing nothing. More or less, this is just guesswork. It can hardly guess anything. Maybe even if you guessed the action ID, you're most likely to perform better than this model. So this is one of the silly, stupid machine learning models we've come across today, right? So if you wanted to do this in a pipeline, you're now combining all this. You're defining the classifier to use. In this case, linear SVC, you're combining the vectorization mode, count vectorizer, and you're defining the parameters as you do it. So this is lumped together, so that when you're deploying the model as well, all these are consistent. They're consistent. So once you create a pipeline, now you use the pipeline to train. So all those things are combined, and the data is trained within the pipeline. Okay. After the training is done, you save your model using joblib into a certain path. And now this is the model that now you will work using either Flask or Django to expose via REST API, okay? And then when you want to do predictions now, once you expose it via REST API, you could choose now to load the model. And this is how you do your tests. And the predicted action according to this is 8. And that marks the end of today's session. And the floor is open for questions and answers. My sincere apologies for the time I've taken. I've eaten into your time for Q&A. Rose, I don't know if
Yes.
you're back. I think I'm done. I'll pass it back to you to drive the rest of the session.
Thank you guys for listening and being part of this amazing NLP session. And thank you, Ayub, for everything. Thank you for the presentation. I enjoyed it. Yeah, I enjoyed it except 20 minutes ago. But it was a really nice presentation. And if we have any questions or something that you'd like to add upon or links you'd like to share, you can put them in the chat section. Or if you'd like to unmute yourself and ask a question, please do so. We have time for the Q&A session for the Q&A. So please, if you have questions, feel free to do so. So as we are looking for questions, I would like to ask mine. I'm having a problem understanding what BAT does compared to Spacey. So can you please elaborate about BAT?
Okay, BAT, BERT is, you could take it as one of the ways to create, to prepare your data before you pass it through to a model. I've mentioned today we've used Word2Vec. There are others that can be used like Glove. So it's a technique within which you vectorize your textual data. That's in English. I don't know if, does it make sense? That is how where it falls in. Rose?
Yes.
Does it make sense to you? Unlike BAT, Spacey, you use it for entity recognition, tokenization. Spacey is synonymous to, let me put it this way. Spacey is synonymous to NLTK with regards to what it needs to do or what it's doing. BERT is synonymous to Word2Vec, with regards to what it needs to do. The approach and the technique is different, but the goal is the same.
Oh, okay. Yeah, I think I will need to do a lot of research on that. But thank you for the insight. I thought it was like Spacey. So we have a question on the chat. What technique can you apply to improve the accuracy of the model from 18% to a higher value like 95%?
It's a combination of so many things. The first thing is how you prepare your data. With NLP, there are certain stuff that are mandatory, depending on the context. For instance, if you have stop words present in your data or you don't have, if you fail to remove them, another thing would be the algorithm you use. Some algorithms are just good in achieving specific tasks. Others are not so good. So you need to be keen on which of this algorithm you might try an algorithm and its output is lower. So that's why I mentioned earlier that you could try 4 or 5 algorithms and then you pick the best. Another thing that would affect accuracy would be the balance of your data set. Okay, this one is based on the interpretation. So if your data set is not balanced and you don't use any technique to balance that data, you're most likely to have a high accuracy, but something that does, it's just like it's guessing. So it also affects accuracy. Another thing would be if you have, if you're using certain, for instance, if you're using a specific algorithm, let's say you build a neural net. There is something called hyperparameters. Even for classical algorithms like random forest or even the support vector classifier, there are something called hyperparameters and the parameters. So whichever parameters you choose can improve your accuracy level. So you might want to, the trick of identifying parameters for any particular algorithm is within Jupyter, you can check out the notes. When you tap on Shift tab, you'll get to see how many parameters. But if you're not sure of how to do the optimization, there's a technique called grid search, where it helps you identify the most optimal values for all those hyperparameters, and then you test them out. You test them out, and you see the way your model performs. So there are several ways, and that is the beauty of machine learning. So, and it boils down now to the reason why a subject like machine learning and data science is a team sport. You need to know and understand the perception of other people and what they think, and they need to help you in your thought process. I'm not so sure if that answers your question. Yes, Abdurrahman.
Yeah, I just wanted to add something to what you said.
Yes, go ahead.
I think the hyperparameter tuning should be left to be the last thing, as it's the sort that introduces most of the overfitting. So if you can pre-process your data in a better way, if you can use a better model, if you can do all of those other things that improve your accuracy first, then you should do that first and leave the hyperparameter tuning last. Thank
Absolutely. You. Thanks, Abdurrahman.
Abel, has your question been answered? So as you type it out, thank you, Abdirahman and
yes, it's been answered.
Okay, thank you. So we have a second question from Rohi. He asked, how can one figure out the human threshold so as to gauge if your model is better or needs improvement?
I think the best approach would be to identify guys who are good in this domain, depending on the chatbot. So you have them as your quality analysts, and they will determine whether it will work or it will flop, because this is a very, very important exercise before you go to production, because you don't want your customers to be the ones to determine for you that, because it might just flop. So in the scenario of a flight booking chatbot, after building the chatbot, after delivering some FAQs and doing that, you need to talk to the best people would be to talk to the customer care agents themselves. They've been answering these questions for the longest time possible, and ask them, can you evaluate according to your judgment? There is something called Turing test, and basically that test is our machine at the point where they can actually behave in a manner that cannot be distinguished from human beings, and the answer is no. Most of these algorithms, especially for chatbots, someone will automatically know, okay, I'm talking to a machine. But to the point where you are actually struggling to know whether or not it is a machine you're talking to, then your chatbot will have passed the Turing test. It's very difficult to get to that point. I'm yet to get to that point myself, but that is the best way to gauge. And the way to, this question is very, very important. The way for you to get that threshold is to talk to the domain expertise themselves, and they will give you, okay, now this is acceptable. And then you can say, okay, now with this, I think we can go to production. After getting, of course, the machine learning classification report. So internally, I wouldn't go to a domain expert with the kind of classification report that I showed you guys. I wouldn't, because as a machine learning engineer, I've just seen from the confusion matrix, it has a lot of misfires. It's the prediction, there's so much, and when you look at the F1 score, it's way, way below the average. So the first thing is for you guys as a machine learning engineer to reach your own threshold in terms of the metrics for your model. And then once you reach that threshold, you now look at the domain expert to audit the responses. Once they agree, then you can go to production. Roy, did that come out well? All right, all right.
Do we have another question? You can unmute your mic and ask.
So if there is no one, me, I have a question. I have a question, Rose.
Yes.
So just by, I know most people are shy of speaking clearly. I asked people to show their faces. I'm alone in the dashboard of Zoom dashboard. People are shy of speaking, apart from a few. My question is this. After this, oh, there's someone who has raised an Asigai. All right, I think it was in error.
Before your question, there's a question on the chat. So let them prepare themselves mentally for the question. So Abel has a question. You used several methods to save and load models. Is there a specific method for each library?
I think the workings of the most common one for machine learning algorithms is a pickle file. Yeah, so you generate a pickle file and you save the model in a pickle file. For Spacey, it saves quite a lot of stuff in that library. Allow me to share the folder. Let me just share the folder so that you guys can get a sneak peek. Share. So when you go to the folder where you have, look at this. This one is a folder where you save the named entity recognition. When you save, it generates all these folders. So it depends on the tool and the model that you are building. For Spacey models, it looks at quite a lot of stuff and it saves it in a folder. For machine learning algorithms, this cuts across any algorithm that you use. When you're solving the model, it generates a single pickle file. Let me just show you guys quickly. The models. This is it. Flight booking model pickle file. So the standard way, the most common way I've come across is generating a pickle file. Abel? We are good? Okay.
You can proceed with the, oh, sorry. Yes, Abdurrahman.
Can you please share the notebook with us?
Yes, I will. Rose will send it together with the video as well as the slides.
Okay, perfect. Yeah.
So we have another question from Bill Robinson. He asks, which version control tool do you use in development?
Version control for, is it building the machine learning algorithms, or is it for housing the model? Because you see, delivering the chatbot, when you're talking about version control of the chatbot is composed of a lot of components, and each of those components, it's important to maintain their version control. Now, the best and easiest of version control I use is the one of given by publicly available repos like GitHub. They have both a repo for collaboration and version control. So as long as you're storing your files there, so if you have a set of components, various components that you're working with in a specific folder, so as long as you upload those and using the techniques provided by the repo, like in this case GitHub, we have GitLab, we have several other repos. You can actually maintain version control, and it has helped me quite a number of times. So that is the approach I use. But there are other version control for specific machine learning models. I prefer the one for working with a specific repo that is collaborative.
Bill, I hope Ayub has answered your question. You can type on the chat section. Okay,
Okay.
Roger that. Asegai is congratulating you, Ayub. Good work, Ayub. Some of us we are not able to talk because some of us are in a noisy background. Okay.
I know. I can relate. As a guy, I think you're trying to compensate the time because curfew. So I can guess where you are. It's okay. As long as you can chat. I might be joining you later.
Okay, so I think we are ready, Ayub, for your question.
It's a simple one. I just want to ask, out of all this, how many guys, just by the raise of hand, how many guys are going to attempt NLP? Is it something that they've thought about? Is it, have they had difficulties? And just comments should stream into Chatbot, whatever it is, chat section. If you'll give it an attempt, if you've learned something out of this, I would like to know what is it that you learned, and what is that one thing that you're going to do immediately after this session? Just one. And guys, please don't keep quiet with that. As a guy, that one you don't need a microphone. You can just type. Bill and every other person. It's good. It's a good thing. For the sake of other people as well, and for the sake of the organizers as well, and also for my sake. All right. Okay. Okay, Eric. I've taken note of that. I'm actually starving. I need to look for that breakfast. Thank you, Joseph. Rosie, that question, I think it's for you.
Ayub, I can also come back to you and ask if you'd like to join us to be with another, you can take us through another NLP session. We really enjoyed this session and you are answering our questions very well. So I would really like you to come back for this session, another NLP session.
All right, no problem. I think we could always work around and think of a topic, and the topic can be driven by the audience of this meeting. So maybe you might want to create a form. I think the planning has a form. If you could leave those comments there, what is it that you'd like for the next session, and then we could always plan and have a similar session. No problem. So I think it's up to you now to get the feedback from the members.
Okay, we'll do so.
All right. All right. There's a question there. Oh, okay. Bill is saying starting an NLP project. Good stuff, Bill. Building a chatbot for a bank. Wow, good stuff. I'm so sure so many guys would want to walk that journey with you. Always, Rose, you might want to maintain this network so that guys who want to network and build a chatbot for a bank, they could do that with Bill and learn through, and within this network, we could support each other. As a guy is saying, I will try and implement a question and answer board for sex education in schools. Wow, good stuff as a guy. And anyone who's interested in that kind of project as well. Rose, kuna kazi hapa. There is some work for you. How to put these people together and make sure that they're not struggling alone, because at times it can be very, very difficult. Rohi initially did Twitter sentiment extraction using R. I think with this I can shift using Python. Wow! So I've converted someone. Karib, welcome, Rohi. Rohi, I'm not so sure if you're in Kenya. If you're not in Kenya, there's a word that we use a lot to appreciate people or to welcome them into Kenya. If there is a Swahili word you need to take home is karibu. Karibu sana. That is welcome. Welcome to Python. That's good. Abel is saying you approached it from an industry viewpoint. I recently implemented a multiple classification LLP model, now equipped to improve it. Awesome. It would be good to hear what you've done and how it was, how the journey was. Abel, Samson, how do you compare TextBlob and Spacey libraries? Now, TextBlob is, okay, it sits within NLTK library, and it has all these capabilities, but it's a bit limited in terms of its capabilities, but it has specific unique capabilities as well. Spacey is more advanced because it does quite a lot, and it's faster and it's lighter as compared to a TextBlob. So the specific tasks like tokenizing, lemmatizing, you can use it using both. For TextBlob, one unique thing that you can do, if you were to start a sentiment analysis problem without labeled data, then you could use TextBlob to look at the probabilities output and help you to label that data. It's a good starting point. And also TextBlob is a very, very good starting point for beginners when you're understanding this concept. So if you want to start learning about all these text analytics, TextBlob is a very good starting point. Spacey is advanced and it has so many features. It hides a lot of difficulties because it wraps some functionalities into libraries, and you can exploit as well. Abigail Oerimo, I had planned on working on a chatbot and didn't know where to start. I hope you know how where to start now, Abigail, and think of a chatbot, and yeah, make sure that you materialize it, because it's different on thinking about something and actually doing it. So if you do it, you'll get better at what you really want to do. In this case, learning NLP. So all the best, and yeah, good stuff. Rohi is appreciating. Welcome, Rohi. Karibu sana. Bill, could you share your GitHub repo for insights? Yes, I will. I'll put it together, and in the document that is shared, Rose is going to share. It will be there. But if you can go to GitHub repo right now, just type A4Ayub. All right, A4Ayub. You'll find my repo there. It's a bit cluttered, and at times I start notebooks, I don't finish. I get lazy, but I hope it's helpful. And then if you get any questions from my notebooks, you can always reach out. Caroline, I will look into more of building pipelines. This I haven't attempted. Endgame is to make a board for use in my job. Awesome, awesome. Good stuff. Thank you, guys. Thank you, guys, for the feedback. It is now up to you to take it to the level that you want and get better at what you want to be. If it's NLP, get better at NLP. If it's neural nets, get better at that. If it's whatever it is you put your mind to. Rose, back to you. I think people have answered my question, and I'm happy now.
Thank you, Ayub, for such a good question.
I was waiting for some deep NLP. But thank you for that informative session. I am so happy the NLP enthusiasts enjoyed the session, and we are looking forward to hosting you once more for another session, depending on the feedback that we get from our participants. So thank you so much, Ayub, for the initiative. You also started the A4Ayub hands-on lab. You can tell us something about it and how it's progressing. You haven't mentioned this.
Okay, thanks for that, Rose. So during my off working hours, I normally have a program I call A4Ayub Hands-on Labs. In this program, it's driven via Zoom as well as a WhatsApp group. And recently, we adopted a new way of learning. So it's a team of people who are complete beginners, who cannot even define what AI is. You put them together with people who can actually explain what neural networks is. You put them together for a common purpose, to understand basic concepts, and for those people who know, to be able to share knowledge with those people who are struggling, and for those people who are struggling to get mentorship and direction on how to achieve specific goals faster. So if without mentorship, I learned that without mentorship and without direction, you will be all over the place, because Google and the internet has answers to almost everything, including lies. So Google has answers built or written by people who have different intentions. So it is always good to, while you seek answers from Google, you need someone to hold your hand, someone or a group of people to hold your hand. So A4Ayub Hands-on Labs, that is the main objective. A group of people coming together, identifying real life projects, and trying to build those projects to take them to production. Yeah, so they are structured. It's structured where there are specific days for specific projects. We have projects on NLP. We have projects on demand forecasting. We have projects for sales forecasting. We have image processing projects, as well as product review projects. So it's quite an interesting space to be in. And my hope is for you guys, wherever you are, either to join similar projects or join A4Ayub Hands-on Labs and contribute, either as an expertise or as a trainee or as a beginner. So that is what we do at A4Ayub Hands-on Lab, driven by what is really valued in the things that we do. When you're building a model, what is the value you're giving? So if you cannot articulate the value you're giving to your customers, then that building that model is rendered useless. So that is the main purpose with A4Ayub Hands-on Labs. I think that's it. That's how much I can say.
Thank you so much for that, Ayub. The session you also hold for in the A4Ayub hands-on are usually on point, and I think you can find the videos on YouTube, right?
Yes, you can find the videos on YouTube.
Yeah. So thank you so much. Thank you so much, Robert Ayub Odhiambo, for everything. Thank you for the amazing session. Thank you for the question and answer session. We really appreciate having you. And also for our participants, thank you so much for joining in today's session. I hope you have learned something, and the recording plus all the resources that you guys have asked for, I will forward them together with a feedback form of a session that you'd like to bring Robert Ayub again to teach us on NLP, or yeah. So if you have something you'd like to suggest, please ensure you have filled the feedback form that will be sent by Deep Learning AI. So thank you guys once more for joining. I would also like to remind you, if you're interested in joining the session that will be held on 29th of July, whereby Andrew will be part of the panelist session, you can also register on the Eventbrite page. Yeah, and also you can join the NLP specialization course that he holds in the Deep Learning AI platform. So Yeah, thank you guys for joining, and thank you for being active and for participating. Hope to see you during the next session, and have a great day or time wherever you are. So thank you guys. And Ayub, since you're our host, you can stop the recording. I can't access my computer right now. It went down. It shut down.
All right. Okay.
Thank you.
All right. Thank you very